Hello, hello, hello. Good morning, good evening, good afternoon, depending from which part of the planet you are currently joining. And I see a lot of familiar and less familiar faces here, and I can't be more excited about this. What is going to happen in next, I hope 4 hours, not more than that, but promise not less than that. So at least 4 hours. We are going to talk about how to pass DP-600 exam and hopefully learn some things about Microsoft Fabric along the way. So the idea is not just to get you ready for DP-600. Of course, that's the main purpose why we are here today, but definitely to have some learnings in general about Fabric as a platform along the way. So without any further talk, I'll jump first into introducing some housekeeping rules, because there are a lot of us here and we are coming from different countries, different continents, different cultures, different backgrounds, different level of skills and so on. So what I wanted kindly to ask every one of you is to be mindful and respectful of everyone in the audience. That means if you are posting something in the chat window, please make sure that everyone feels safe and comfortable being here today. And yeah, that's my message to you basically. Few more things that I wanted to mention is if you have questions, and I will come up in a few minutes to explain and talk about people who will help this event going seamlessly. So if you have any questions, feel free to drop them in the chat for this live stream. And we have amazing people in the audience who will happily take and try to answer all of your questions. If there are some questions, I will watch recordings after the stream, and if there is any question that was not addressed during the stream, then I'll try to pick them up and do either a follow-up stream or to answer those questions, to address those questions through my blog. So without any further talk, and then, yeah, don't forget to prefix your questions with letter Q, so that moderators can immediately spot and differentiate between the questions and some other comments. Of course, you are feel free to enjoy discussion and talk about Fabric, talk about everything related to data, and that's why we are all here, basically. So I'll start sharing my screen for the beginning, and let's go. So the title of this live stream is DP-600 Fabric Analytics Engineer, and in the first few minutes I'll do a short introduction about this exam itself and why you would consider taking this exam and becoming a certified Fabric Analytics engineer. So before that, of course, as every good host, I want to introduce myself. My name is Nikola. I'm originally from Belgrade in Serbia, but for last almost 9 years, I live in wonderful city of Salzburg in Austria, where I work as an independent data platform consultant and trainer, focusing mostly on work with Power BI and Microsoft Fabric. Living in Salzburg was the reason why I've chosen this nickname Data Mozart. So it doesn't have anything to do with my love to classic music or whatsoever. I'm not a big fan, to be honest, of classic music. But yeah, you probably know that Salzburg is worldly known as a birthplace of Wolfgang Amadeus Mozart. So I was, let's say, brave enough to use his last name as part of my nickname. And that's why I'm trying to make music from the data. I'll also try to follow what's going on in the chat, but yeah, please don't mind if I don't react to all of your messages immediately. I have few screens all over the place, so I'll try to cover everything as much as possible. Currently, what's interesting maybe for all of you, at least it is for me interesting, I'm writing a book together with my friend Ben Weissman for O'Reilly, which is called Fundamentals of Microsoft Fabric. We are almost halfway done, so you can go on O'Reilly's platform and read the chapters that we already wrote and published, and we expect to have a printed edition in the Q1 or Q2 of the next year. So it depends on different things, but yeah, we hope to have it soon, and we hope that there will be not so many changes in Fabric because we already had to rewrite our chapters so far a few times. Yeah, that's something which is relevant for Fabric. Things are developing and evolving so fast, so it's hard to stay up to date. But yeah, we are doing our best. Before we start, a huge round of applause for these wonderful people you see on your screen. So Parv, Johnny, Govind, Tom, Pragati, Eugene, Miguel, Rubayat, Andy, and Shannon, and I will mention few more people on top of that. So these 10 wonderful people will assist you today with providing answers to your questions. And let me just briefly provide you with a little more of a background how it came to this point. Yeah, you don't want to see this. So essentially, when I started this initiative approximately a month ago, I didn't even dream that so many people will be interested to join. And obviously, because I'm alone here and I tend to present and do some demos and show stuff, so it's hard to complete everything and monitor the chat, answer the questions, because I expect there will be many questions. So I was thinking, what should I do now? How should I handle the questions from the audience? And then I reached out to my friends from community, and they immediately responded, wanted to join and help with this initiative. So I'm hugely thankful and grateful to all of you. And for all the others in the audience, I hope you appreciate the effort and time that these people will spend the next 4 hours trying to help you master all the skills relevant for DP-600 exam. There will be two more persons that I want to explicitly mention. One, it's Pam Spear or Spire. Sorry, Pam, I don't know if I pronounced your last name correctly, from Microsoft. So she's not helping with technical moderation. So she will not answer to your technical questions, but all the questions that you have specifically for exam logistics, like if there are any more free vouchers or so on, please ask, and Pam will make sure to answer those questions. Okay, so what are the goals for our session today? It's Spear. Oh, good. Okay, then yeah, I'm fine. I'm good with that. Okay. So what are the session goals for today, next 4 hours? First, obviously, you all came here to learn something, right? So yeah, that's the main goal of our session today. But what shouldn't be underestimated at all is to have some fun. And I'm a huge advocate of learning while having fun, because learning just for the sake of learning sometimes can be, boring or overwhelming. Remember, in school, we always loved those professors and teachers who brought some fun into the process of learning. So that's what I'm trying to do. It doesn't always work well, I have to admit, but yeah, I'm doing my best. So I'll try to do again my best today to help you learn some things relevant for passing DP-600 exam and have fun along the way. So let's quickly introduce and do a short overview of DP-600 exam and DP-600 certificate, which is officially called. So once you pass this, once you complete this exam, hopefully after watching this session and after completing challenges and walking through Microsoft's documentation, the official title you will receive will be Fabric Analytics Engineer. And that's this very nice badge that you can put on proudly on your shirt. So essentially, DP-600 is the exam that, or is certificate that consists of only one exam. And this exam is called Implementing Analytic Solutions Using Microsoft Fabric. Why am I emphasizing this, that this is one exam? If you took certain Microsoft exams in the past, you're probably aware that certain certificates consisted of multiple different exams. We don't need to go too far in the past. So like 2 or 3 years ago, for Azure Data Engineering certificate, you had to pass 2 separate exams. Now it's one, but it used to be 2 exams. let alone going back for MCSA and MCSC in SQL Server, there were like 5 different exams to pass. So here, good news is you need to learn and pass just DP-600 exam, and you are getting certified. So this certification is for you if you are working or you are interested in the fields of data analysis and data engineering. Obviously, no one is prohibited from taking DP-600 exam, but I would say the target audience for this certificate are those professionals, those people who are working or plan to work in data analysis and data engineering realm. And finally, you should to be able to successfully pass this exam, you should understand various features and services in Microsoft Fabric. What is, let's say, desirable candidate profile? So who should take this exam? This is a person who has expertise in designing, creating, and deploying enterprise scale data analytics solutions. This sounds scary, so let's break this down. Some of the responsibilities included in the description of this role contain preparing and enriching data for analysis, securing and maintaining analytic assets, and implementing and managing semantic models. You see who these professionals should help in their professional work. And I don't want to go and read through these slides because, yeah, I will send the presentation to all of you who register for this session, so you can go and read on your own. But what is important, and I want to stress this thing here, because a lot of people approached me and asked, okay, I'm doing this and that, I know this technology, I know this language, should I take DP-600 or not? So this is something, this is a list of skills in terms of programming languages and some concepts that you need to know in order to complete DP-600 exam. So we are talking about advanced Power BI skills. No data visualization. So if you are great at building nice looking reports and dashboards, maybe you want to spend some time learning some background stuff when it comes to Power BI. Power Query and DAX, so you don't need to be Power Query Ninja, knowing all M stuff, programming custom connectors or whatsoever, but you need to know Power Query, and especially from the perspective of what can be done within Power Query. Obviously, DAX. Yeah, if we talk about advanced Power BI skills, DAX cannot be excluded. Then T-SQL and KQL. So this part slightly changed. For those of you who were considering taking DP-600 exam before mid-November, there was no KQL included. It was T-SQL and PySpark. And now Microsoft decided to change the curriculum of DP-600. We can also talk about that if there is enough time by the end of this session. So now PySpark is not there anymore. There will be maybe some questions here and there that will ask you how to do certain stuff in PySpark. But generally speaking and officially, now KQL or Custo Querying Language will come up later to explain what is KQL and in which scenarios it's used. Now KQL is officially part of DP-600 exam. And there are a lot of data modeling concepts and techniques that you need to know in order to be able to answer properly to those questions that are related to data modeling. So data modeling in general, we are going to talk about certain concepts, but data modeling in general with special focus, obviously, because we are talking about the analytics solution. Obviously, the emphasis is on dimensional modeling and building star schema. So as of 15th of November, again, exam curriculum changed back then. This is what you are going to be tested on, and in terms of the amount of questions that you can expect during the exam, you see percentages for each of these skills that are measured. So there are three core components of skills measured within DP-600. Maintain a data analytics solution, which increased after 15th of November. preparing data, which is almost half of the exam, and then implementing and managing semantic models. So those three, we are going to break this down during the session, all of these three into smaller subsets and cover everything that is included in those three skill area measured. But let's take one step back, because yes, as I mentioned, and I see there are more than 300 people currently on the stream, so maybe not all of you are familiar with Microsoft Fabric. But honestly, if you don't familiar, if you never heard about Microsoft Fabric, you probably don't have internet, or I don't know, you were in coma in the last few months. But yeah, joke aside, let's first take one step back and explain what is Microsoft Fabric. And for all of you who know me, you know that I'm a huge football fan, or soccer for all of our friends from USA. So in a football team, you have players with different skills, let's say. They play in different positions, they have different characteristics and so on. For example, you have very fast players who can play on wings and utilize their speed to create chances for your team. Then you have strong and tireless players who can excel in defense. Finally, we have players who are skilled to score goals, we have a goalkeeper and so on. Now imagine yourself being a coach of this team. So you have all these players at your disposal, and your task is to establish the system that best fits your players with winning the match as the ultimate goal. So think of Fabric as the data football team, and Microsoft provides you with players, and your task is then to integrate these players into the system that will ensure success. And these players are already well known, some seasoned stars, such as, I don't know, Azure Data Factory or Azure Synapse Analytics or Power BI. But there are also some fresh faces, some newcomers that should bring fresh blood to our team. And we will examine most of these players throughout this session. At this moment, it's important to understand that Microsoft Fabric is not some new fancy tool. It's essentially a suite of individual analytical tools and services that work together in synergy to provide a unified analytics experience. Now, what does unified mean in the context of Microsoft Fabric? First and foremost, it's about a unified experience. Whether you look at a single workspace experience, single sign-on experience, single storage format, all the way to single experience for managing security and collaboration. So when we talk about the players in Microsoft Fabric as of today, and I need to repeat this sentence, you will hear me repeating this sentence as of today, because things are changing very fast in Fabric world. And if this session was delivered 3 or 4 weeks ago before Ignite, then this part here, databases, would not be here. So this one was introduced at Ignite, and thanks to Microsoft for making me, forcing me to make changes to my slides every few weeks. But yeah, never mind. So those are the players in Microsoft Fabric. We have one lake as the central storage repository of the entire platform. We are going to talk about one lake in more detail very, very soon. And then Copilot in Fabric and Microsoft Preview, it's out of the scope definitely of this session, because it's also out of the scope of the exam. But also when it comes to different, let's say, ways to process and handle your data from a perspective of compute layer, there are different experiences that you can see on the top, like Data Factory, real-time intelligence, databases, and so on. We will cover some of them, those that are relevant for DP-600 exam. So what is out of the scope of this session and what is out of the scope of DP-600? I'm not saying you don't need to learn this, but if you are just preparing purposely for passing DP-600, you don't need to know databases, you don't need to know industry solutions, you don't need to know copilots, you don't need to know Microsoft Preview. So what's in the scope? Data Factory experience, real-time intelligence, analytics, which includes, under this analytics umbrella, we have multiple different things that we are going to examine. Obviously, Power BI, we already mentioned that you need to have advanced skills in Power BI. and some concepts that are relevant to One Lake. So not necessarily everything that that One Lake is, but certain concepts which comes into play when we are talking about the role of analytics engineer and how you can leverage this role by using data from stored in One Lake. Okay, so let's start with the basics and let's break down some of the key terms that you will hear when working with Microsoft Fabric. And I thought it would make sense to structure this part hierarchically, so we'll kick it off from the highest level, which is a Fabric tenant. A Fabric tenant is a dedicated space for organizations to create, to store, and manage different Fabric items. There is often a single instance of Fabric for the organization, and it's usually aligned with Entra ID, or formerly known as Azure Active Directory. The Fabric tenant maps to the root of One Lake, and this is at the top level of this hierarchy. Then we have a capacity. Capacity represents a dedicated set of resources that is available at a given time to be used. One tenant can have one or more capacities which are associated with this tenant. And capacity defines the ability of resource to perform an activity or to produce certain output. Different items can consume different capacities at a certain point in time. And Fabric offers capacity through Fabric SKUs, so F SKUs, and trials. So you can play on your own. If you don't want to buy capacity, you can use trial, but we'll also come later to talk more about that. Then we have the next level is a domain. Domain is a logical grouping of workspaces, and domains are used to organize the items in a way that makes sense for your organization. To be honest, data mesh approach that became extremely popular in the last few years introduced this concept of domains, and Fabric simply follows this path of providing tools to support data mesh approach in your organization, meaning you can create a domain for different departments in your organization, such as, I don't know, sales or marketing or HR and so on. And these domains are just a logical group of different workspaces. Since I mentioned workspace is the next in this hierarchy level. A workspace is a collection of items that brings together different functionality in a single tenant. It acts as a container that leverages capacity for the work that is executed, and also serves as a control center. So you control the access, who can access items in the workspace by implementing certain permission policies that we are going to examine also throughout this session. For example, I will give let's go with a simple example. In a sales workspace, users associated with the sales organization can create different items such as warehouse, I don't know, they can run notebooks, create semantic models, and so on. And at the lowest level of this hierarchy is an item or Fabric items, and essentially they are the building blocks of the entire platform. So let aside now tenants and capacities and whatever. Without items, without Fabric items, all this story doesn't make much sense. So items are the building blocks of Fabric platform. So those are the objects that you create and you manage in Microsoft Fabric. And there are different types of items, such as data warehouses, lakehouses, pipelines, semantic models, many more. We are going to examine a lot of them today, but please keep in mind that although we are covering some of those items that are relevant for DP-600, there are many more that exist outside of what is mentioned in this session today. Okay, so let me quickly take a look at the chat. I see everything is fine so far. Okay, good. Then we are ready to jump into our first big sub lesson, which is called maintain a data analytics solution. And this part consists of two subtopics: implement security and governance, and maintain the analytics development lifecycle. So let's go. You see, I took this from the official Microsoft skill measured for DP-600 website, which is also included as part of the presentation. So we will go and check one by one all of these points that are listed in both implementing security and governance and maintaining analytics development lifecycle. So let's start first with implementing security and governance. You see which subtopics are included here. So let's start with understanding different levels of control in Microsoft Fabric. Obviously, this platform is humongous, it's huge, and there are different levels where you can control who can access or who can see what. So let's start with the highest possible level, which is a workspace level. And let's imagine that we are in the company, in a huge company, and they have a lot of workspaces, a lot more than these four, but for the sake of simplicity and understanding, let's say that they have 4 different workspaces, A, B, C, and D. Now, in each of these workspaces, as we already learned in the previous slide, there are multiple items that reside in these workspaces. And for example, in workspace A, we can have a warehouse and a lake house. Then in workspace, I forgot to include the line here. So let's say in workspace C, we have an event house. In workspace D, we have semantic model. Probably many of them, but again, for the sake of simplicity, I just want you to be able to distinguish between different fabric items. And then we have different objects that can exist in the specific item. So I can give you a simple example. In my warehouse, I will probably have tens, hundreds of tables, some views that I also created. Within the lake house, I also have a table, which is in Delta format, and so on and so on. So this is an individual object level. So there are many objects, potentially many objects, and commonly many objects that exist in each of those fabric items. And finally, the lowest level, or let's say if we talk about the granular access that you can control, is the row level or column level access. This means in DIM product, we can have, I don't know, 25 different columns, and we want to restrict access to certain columns for a specific group of users, like product color, for example. That's the lowest level of granularity for controlling who can access what. So this is from a high level perspective how fabric workloads are structured in terms of giving the access and providing the access to these different levels. So how access control work in Fabric? Again, let's take a simple example. I have a workspace A, and I have 3 different items in this workspace. I have a semantic model, I have a lakehouse, and I have a pipeline. Now, if we control the access on a workspace level, if we assign user or a group of users to a certain role, and we will discuss what roles exist currently, they will get the access to all the items in the workspace. So based on their role, they will get access to all the items in the workspace. That's the workspace level access. Whereas item level allows me to define a single individual item within the workspace that can be accessed by a certain user or group of users. So it allows me to go one step, one level more in this granular control and say, look, I don't want to give you access on a workspace level because then you will see a semantic model and pipeline. You just need access to a lakehouse. I will give you access just to a lakehouse from this workspace. So those are from let's say 10,000 feet high level perspective, 2 different options for granting access in Microsoft Fabric. Now we will examine in more nuances how this works. Let's start with the highest level, which is workspace access control. As I already mentioned, there are 4 different roles that can be defined on a workspace level. And those are admin, member, contributor, and viewer. Now, what I strongly suggest you to do for taking DP-600 is to try to learn and memorize what each of these roles can do on a workspace level because there will be, for sure, there will be some question that will ask you, user A needs to do that. What is the minimum permission or minimum, let's say, the role with least privilege that can allow them to do that? So try to remember this table. It's taken from Microsoft's official documentation, so you can also go there and try to find it if it's easier for you. But definitely something that is super important and that is 100% tested on DP-600. So workspace roles, those are four. There are four workspace roles. You can see which of them are here. Remember, when you assign user or group of users to a specific role, they will have access to all the items in the workspace. So if you assign someone to a viewer role, they will see all the items in the workspace. They can't change them, but they can see them. Okay. For others, depending on the role, they can also do many more things. So please be aware when you assign those roles, because yeah, in real life you should think twice. Yeah. And again, it's thinking about assigning an individual user or Enter ID or M365 group of users. In theory, you can do both, but in real life, especially in huge organization, you probably don't want to assign individual users to roles. It's a recommended practice to handle this through Enter ID or M365 groups. So you first assign user to an Enter ID or M365 group, and then you assign this group to a specific role. It's much easier to control them. Okay, so then we are moving to the next level, which is item level access control. And item level permission is used to control access to individual Fabric items within a workspace. Item permissions are relevant to a particular item and don't apply to other items. So unlike with workspace roles, this one is relevant just for a specific particular item. And you should use item permissions to control who can view, who can modify, and manage individual items in a workspace. Why is this important? Because you may want to use item level permission model to give users access to a single item in a workspace that they don't have access to. So I don't need to have access to workspace A, but if someone shares the lakehouse from workspace A with me, I will have access to this lakehouse. When you're sharing the item with the user or group, you can configure different item permissions, and sharing an item grants the user the read permission for that item by default. Read permissions allow users to see the metadata for that item and view any reports that are connected with that item. However, read permissions don't allow users to access underlying data in SQL or OneLake. Different Fabric items have different permissions. In this example, I'm showing you the item permission model of the lakehouse item. And I strongly suggest you going to this link, item permission model. Then you will see for each specific item that can exist in Microsoft Fabric, which permissions can be granted and what is the effect of giving those permissions. So granting people access here, for example, on this lakehouse, if I don't check anything, this means they can access lakehouse from one lake hub, but no tables can be accessed. So just lakehouse, but none of the tables. Now, depending on what you set here as permission granted while sharing, read, edit, share. This one is interesting. Read all with SQL Analytics endpoint. This means, as you see in this table on the right-hand side, they can read data from SQL Analytics endpoint from lakehouse or warehouse and so on. Also read with Apache Spark, meaning that they can use Spark to read lakehouse data, and also through Lakehouse Explorer. So again, this topic alone can be like 60 minutes. Therefore, I included this link, and I strongly encourage you to go there and try to understand this concept of item level access control. The next concept is role level security. We are talking not about role level security in Power BI. This is not a topic for DP-600. This is included, I think, in PL300, which is Power BI Data Analyst exam. but we are talking about implementing row-level security in the warehouse and SQL Analytics endpoint of the lakehouse. And implementing row-level security there enables you to control access to rows in the table based on user roles and based on predicates. To implement row-level security, you need to ensure that certain prerequisites are in place. The first step is to define a security policy. So it starts with determining the roles and predicates you want to use to control the access. And roles define who can access the data, whereas predicates define criteria for access. This means security predicates are conditions that determine which roles user can access. You can create these security predicates, as you see in this example, by leveraging inline table value functions in T-SQL language. So the first step, I'm creating a separate schema for security, and then this is the function where essentially I'm taking the username of the user who logged in, and then I'm just using this value to filter out the records that this specific user can see. And then finally, I'm using this function to create a security policy. So once again, this is row level security on a level of the warehouse or SQL Analytics endpoint of the lakehouse. This has nothing to do with row level security that you establish on semantic model for Power BI. To be able to create row level security, you either need to be an admin member or contributor on the workspace, or to have elevated permissions on the warehouse or SQL endpoint. So there are certain permissions that are specifically granted for working with warehouses and SQL Analytic endpoints. So those are elevated permissions. That means elevated permissions. Then the next concept is object level and column level security. So object level security enables access restriction on the database object level, such as table, for example, whereas column level security allows you to restrict access to specific columns of the table. So it's more granular than object level security. Please keep in mind that object level and column level security are applied on a database level, which means that whenever any application or reporting platform, including Power BI, tries to access the data in a warehouse or SQL endpoint in the lakehouse, these rules are applied, these rules are enforced. This means if you enforce object level, row level, or column level security in a warehouse or SQL Analytics endpoint of the lakehouse, if you have a Power BI semantic model in a direct lake mode, all the queries will automatically fall back to direct query. Please keep this in mind, and this can be used as a trick question or something like that in DP-600. I'm not sure if that's going to happen, but this is one, I wouldn't say downside of doing object level and column level security and row level security. Obviously, this is not a downside, but more of a consideration and limitation in the current architecture and way of working with direct lake semantic models. So when you implement this, there is no direct lake, okay? So direct query will be enforced. Again, what are the necessary permissions to create those three? And then we have folder level access control. Data access role security only applies to users that are accessing one lake directly. Fabric items such as SQL Analytics endpoints or semantic models and warehouses, they have their own security models and access one lake through a delegated identity. This means that users can see different items in each workload if they're given access to multiple items. So in this case, we are talking about what is currently supported. Currently, it's supported only for the lakehouse item. But again, as of today, so yeah, this will probably be supported for other items in the future. Currently, it works only for lakehouses, and this is from the user interface perspective. When you define a new role in a lakehouse, you see that feature is still in preview. And this is, for example, I am creating a role which is called Read Adventure Works, and then I'm including only tables that are relevant for AdventureWorks database. I also have some tables from Contoso database, but this role here, when the user belongs to this role, when they try to access, when they open this lakehouse, they will not see Contoso tables at all. So first you create a role, then you choose the tables from or files. You can also define for files from lakehouse, and then finally you assign role to user or a group of users, which is a recommended way again. Okay, so the next topic is sensitivity labels. Sensitivity labels, they are defined in Microsoft Purview information protection on items there, and the idea is to protect your sensitive content against unauthorized access, obviously. So sensitivity labels are one of the most important components in helping your organization to meet its governance and compliance requirements. And labeling your data correctly with sensitivity labels ensures that only authorized people can access the data. There are two ways to apply sensitivity labels in Microsoft Fabric. And before I show you those two, keep in mind that they need first to be created in Purview. So you can't create sensitivity label in within the Fabric itself. You need first to go to a Purview, you create sensitivity labels, and then Fabric will offer you to use to choose those sensitivity labels that were previously created in Purview. So two ways to apply. You can either choose between using a flyout menu or directly on the item. So you open the item, and in item settings, like in this case, I have a KQL database, and under sensitivity label, I can set different sensitivities. In this example, it's confidential. So that means that everyone who tries to access this data downstream, either through directly querying this data or using a reporting platform or so on, this sensitivity label will be propagated and applied. And finally, we have endorsement, concept of or feature of endorsement that makes it easier for users in the organization to find high quality or trustworthy content and data. You can easily recognize endorsed items in a workspace because they are clearly labeled and they have a badge. When we talk about the badges for endorsement, there are three different badge types. First one is promoted. With promoted, item creators, so they think the item is ready for sharing and reuse. So any Fabric or Power BI item except Power BI dashboards can be labeled as promoted. And any user with right permission on an item can promote it. So any user who has right permissions can do a promotion. Then we have certified. Certified, that means that organization authorized reviewer has certified that the item meets organizational quality standards and can be regarded as reliable and is ready to use across the entire organization. Again, any Fabric or Power BI item except Power BI dashboards can be certified. Now, any user can request certification for the item, but only users that are specified by a Fabric administrator can actually certify items. That's big difference compared to promoted. And finally, we have master data. This means the data in the item is a core source of organizational data. That's usually used to indicate that data item is to be regarded as a single source of truth for certain kinds of organizational or business data, such as product codes or customer lists and so on. The master data label can be applied to items that contain data, such as lakehouses and semantic models. So you need to have physical data to be able to apply this master data badge. And only users, again, only users specified by the Fabric admin can label data items as master data. This is how, this is a simple example of these badges in Workspace. So you see some of them are labeled as master data, some of them are labeled as certified, some of them promoted, and so on. So this is how you will see those badges appear when you open the Workspace. We are done with the first subtopic. Not bad. Let me just take a look Okay, so I see that everything is running so far. Thanks everyone in chat. I really appreciate the help and support. I wouldn't be able to monitor everything and answer all these questions. So thanks again, everyone. Okay, so let's jump into our next subtopic, which is maintain the analytics development lifecycle. And we are starting with very cool feature, which is called version control for a workspace. This means that you can now define or synchronize the content of the workspace with your source control system. To be able to do this, it's fairly easy and straightforward from an end user perspective and from web UI. As you see, there are just two things that you need to pay attention on: source control and Git status. So Git status says that, for example, this report here is not committed, and I have one warning sign in my source control button which says that I have to pay attention to on something. But again, from an end user perspective, that's enough. So you can simply choose to synchronize the content of your workspace. But I would encourage you, especially if you're working in larger organizations where multi-developer teams work on creating and managing content, to try to learn and understand basic concepts that are relevant for version control. So those are concepts, Git concepts like what is a branch, what are commits, what are pull requests, what does it mean to merge something, and so on. Currently, for this feature in Fabric, there are two supported providers, Git in Azure repos, and or let's say three, GitHub and GitHub Enterprise. What can be done? So you can sync the content from Git, which will override the content that you currently have in the workspace. Then you can commit changes to Git, so do the opposite in the opposite direction. And you can also branch out the content of the workspace to a brand new workspace. So that's also possible. Currently, almost all Fabric items are supported. If there are some unsupported items, this doesn't mean that the process of committing changes or pulling the request or doing a pull request will fail. No, unsupported items will simply be ignored during the process. And it's important to keep in mind that only workspace admin can manage connections. I see some donations. I really appreciate that. Thank you, Victor. Thank you so much. Thank you. I really appreciate that. Next topic that we are going to cover is Power BI Desktop Project, or among friends also known as PBIP. Now, this one is still in preview, but that's, if you ask me, this is one of the greatest enhancements to Power BI in the last few years. What is Power BI Desktop Project? Let's try to first to demystify this. It introduces a new way to author and collaborate on Power BI projects. And when you are done with the work and you save it as a Power BI project, there will be two separate folders. I will show you a demo in a few minutes. I know we all like to see things in action, but yeah, bear with me. So report folder and semantic model folder, and they're both saved as individual plain text files in a very intuitive form. So let's break down key advantages of using PBIP format when working with Power BI. First is text editor support. Trust me, I will show you in 2 minutes. Definition files are JSON formatted text files which contain semantic model and report metadata. And these files are human readable. While project files support simple text editing tools like Notepad or Notepad++, of course, it's better to use let's say, more sophisticated code editor like Visual Studio Code or similar, which provides a rich editing experience, including Git integration. Then scripting and editing definitions. So you can create scripts using either TMSL or TMDL language. So tabular model script language or tabular model definition language, which is now new standard. Again, I will show you how it looks like. Source control. Power BI semantic model and report item definitions can now be stored in a source control system like Git. Keep repeating this. Power BI semantic model can now be stored in a source control system like Git. Why is this so important? So for years, and still PBIX, the regular format that we know for Power BI since Power BI appeared, it's just a binary file. So you can't really do a version control on binary file. You can't track changes and so on. And this is why Power BI desktop project is a big deal in Power BI. So now you can do a proper source control. Also for CI/CD operations, you can use systems where developers in your organization submit a proposed change to the system, and then the system validates the change and perform a number of quality gates before applying the change to production system. These quality gates can include, I don't know, code reviews, automated testing, and then automated build, and so on. So let's quickly go and I will show you what I'm talking about. So I'm in Power BI desktop, and first and most important thing, because Power BI desktop project format is still in preview, so it doesn't allow you to save your Power BI work out of the box as PBIP. You need to go to File, Options and Settings, and then under Options, find Preview Features, and then Power BI Project Save option. You can choose 2 additional sub items. This one you probably don't want yet, PBIR. You don't want yet in real life. And this one says store semantic model using this new TMDL format. So you first need to enable this preview feature. And then once you save your Power BI work as PBIP, what you get is the following. So here what I did, I saved my Power BI report as PBIP, and I have 2 different artifacts. I have report and I have semantic model. And now let's just open semantic model. And for example, under definition, I can see different properties of this model, like what is the compatibility level of this database. Then I can also see, for example, each individual table. So if I click on collisions, this is what I was talking about. This is TMDL. It's human readable. And then you can see for this table, you can see all of its columns with formats, data type, source column, and all the other properties defined for the specific column. Which means now, since you have this in a text file, and someone make a change, you can easily compare 2 text files and see what has been changed. Let alone that you can apply change here, save it back, and it will be applied. But for proper source control, this is really a huge feature. So it's just, as I said, it's just a text file. So for every other table and every other, also for the report itself, you can see all the details about the pages, about the visuals, and everything is stored in this nice format, which allows you to easily manipulate. Okay, deployment pipelines. That's also one of the improvements that Microsoft introduced not so long ago. Let's be honest. I think deployment pipelines were introduced maybe 3 or 4 years ago for Power BI items, and now since Fabric is a thing, and Power BI is just part of the Fabric deployment pipelines, we are talking about deployment pipelines for Fabric items. So in a nutshell, they represent an efficient and flexible way of automating the movement of Fabric artifacts through different development lifecycle stages. With that in mind, there are usually 3 stages or 3 environments of the development lifecycle in Fabric deployment pipelines. I said usually, you will understand soon why. First one is development. And you should use development environment for design, for review, for playing around with Fabric content, and so on. This means you can start small, you can use minimal data sets for development, and once you are sure, once you confirm that content is ready for review, you can push it to the next stage, which is test. Test, this is a pre-production environment where you should test and verify that the content meets certain criteria in terms of quality, performance, and so on. In this environment, you should run tests on larger data volumes that are more realistic in production environment. But also you should test, for example, if Power BI app works properly to confirm that it's fully ready for end users. Once you confirm that the content is at the level necessary to meet end users' expectations, you will push it to the third and final stage, which is production. And this is the final version of the content, and it needs to provide the highest, the highest possible level of quality and data accuracy. Please keep in mind, again, this structure is not set in stone, as you can define between 2 and 10 deployment stages, depending on your specific needs. Therefore, I told that this is the usual workflow to have a development, test, and production. But I don't know, if you don't need development, if you just want test and production, that's also fine. If you want to introduce some additional layers in between, that's also fine. So between 2 and 10 different environments are supported for deployment pipelines. And also what you can do is you can choose between all versus selective deployment, meaning I can either choose to move all the items from the workspace to the next environment, or I can select just specific items. If I have, I don't know, 100 different items in my development environment and I made changes just on 2 or 3 of them, I will push only those 2 or 3 items to the next stage. No need to do a full deployment. Okay. No moderator. Oh, sorry. Give me a second. I didn't see Johnny and Andy. Give me a sec. Give me a sec. So just a moment. So I need to assign them as moderators. This will take me a few seconds. Apologize, folks. So Johnny, Andy, now go wild, guys. You have the power. Okay, thanks. I just spotted that. Sorry about that. Okay, let's move on with deployment pipelines and talk about them in more details. So this is the usual workflow that happens, that is the typical for development lifecycle management. Few things to keep in mind. The content and workspace can be different in each stage. For example, if you take a thorough look at the size of the data source on this illustration on the left-hand side, you will probably notice that it starts with the smallest one. It's a table. And its size grows as we are getting closer to the production environment. Next, you may also spot that the report, which is represented as a chart icon here, is also changing between the requirements. So these are the things. You can also define separate workspaces for each stage. So those are the things you should keep in mind when defining deployment workflow for deployment pipelines. Obviously, you can use REST APIs and DevOps to automate the process, and you can also configure rules to allow changes. We'll talk about defining rules on the next slide. Essentially, what you also should keep in mind that once you deploy the content from the, let's say, development to test stage, the equivalent existing content will be overridden. To simplify, if you have a semantic model named sales in your test environment and you deploy the sales model from the development environment, the existing sales semantic model in the test will be overridden. Those are the items that are currently supported for deployment pipelines in Microsoft Fabric. And again, always check the list of supported items. You see the link down below. Maybe this link should be written in bigger font. Things are changing here rapidly again, as everywhere in Fabric. So supported items, list of supported items is growing. I can't say week over week, but let's say month over month. And this is the list of items that are currently supported for deployment pipelines. Try again the same as for workspace roles. Try to memorize this list because you will be tested on DP-600. For example, you implement a deployment pipeline. You have this, and that in your workspace. Which of these items will be or will not be moved or to the next stage? Therefore, please try to memorize this. Okay, and this is the usual deployment pipeline workflow. This is a new user interface that was recently introduced, and once you start creating your deployment pipelines, this is what you will see as an end user. Item pairing is the process by which an item is in one stage of the deployment pipeline is associated with the same item in the next stage, and paired items appeared on the same line in the pipeline content list. Items that are not paired for whatever reason appear on a line by themselves. As you see in this illustration, I have a data flow which appears only in the source but doesn't appear in the next stage. So this one is not paired. Keep in mind that paired items, they remain paired even if you change their names. So paired item, this brings us to a conclusion that paired items can have different names. That's one thing. Another thing to keep in mind regarding pairing is items added after the workspace is assigned to a pipeline are not automatically paired. This means you can have identical items in adjacent workspaces that are not paired. So you need to perform this afterwards. Those are some, I think, useful examples I took from Microsoft Learn documentation, which shows you different examples of when pairing occurs versus when not. So yeah, again, try to walk through this and understand item pairing is one of the very important concepts in deployment pipelines. And finally, I already mentioned deployment rules. When you are working with deployment pipelines, different stages may have different configuration settings. For example, each stage may have a different database or different query parameters. Also, development stage might be used only to query sample data from a database, while then you have, for example, test and production stages to query the entire database. Configuring deployment rules enables you to allow changes to content when you deploy content between different environments. For example, if you want a semantic model in a production stage to point to a production database, you can define a rule for that semantic model. The rule is defined in the production stage under this specific semantic model. And once you define the rule, content deployed from test to production will inherit the value from deployment rule and will always apply as long as this rule is not changed and as long as this rule is valid. So let's wrap up this first topic of maintaining a data analytics solution with a story about creating reusable assets in Power BI. Or sorry, first we are talking about performing impact analysis. Performing impact analysis allows us to understand and review the potential impact of changes that we are making to fabric item. So there are two places where we can find or where we can perform impact analysis. First is lineage view in the workspace, which you see this icon in the bottom right corner, and another one in item details page. So if you click on the specific item and then you open this lineage drop down menu, there is an option to see impact analysis. Once you click on impact analysis, you can choose to see impact analysis from two different angles or perspectives. You can browse by item type, as you can see on the left hand side. This means, for example, this data set will have an impact on 5 different reports and 3 different dashboards. So this is by item type. Or if I do and check browse by workspace, then I can also see what is the impact of this data set, in which workspaces this will have an impact. So by item type or by workspace. And there is a cool option when you change something, definitely, to notify contacts. So all the people who are listed as contacts for the certain item will be notified that there is a change, and then yeah, they can act accordingly. So next topic, semantic model deployment through the XMLA endpoint. So first of all, what is an XMLA endpoint? Let's take one step back before we explain the process of semantic model deployment. So essentially, XML endpoint is the feature that allows communication with a semantic model. So like we people communicate between each others, also different tools and different services communicate between each other. So semantic model has this XMLA endpoint, which is exposed by semantic model, and then different external tools can use this XMLA endpoint to communicate with semantic model. When I say communicate, this means either reading the data from semantic model or reading and writing the data to semantic model. So it's choosing between if you just want to allow that someone just access the data and read it, or do you also want to allow changes from outside through this XMLAS endpoint. By default, it's read-only in your Fabric tenant, but definitely with read-write, it allows more flexibility, more options for managing model, for configuring models, for implementing some advanced uh, modeling techniques and concepts such as custom partitioning, for example, and so on. And when we talk about XML endpoints, there are two mainstream external tools that are being used in conjunction with semantic models and XMLA. First is DAX Studio. DAX Studio leverages read-only XMLA endpoint because it just reads the data from your semantic model. Whereas Tabular Editor, in this case, we are talking about the free version. There are two versions of Tabular Editor tool. And as a small digression, I sincerely hope that you are using both DAX Studio and Tabular Editor if you work with tabular models. So they are amazing tools. Again, DAX Studio is completely free. Tabular Editor has two versions, Tabular Editor 2, which is a free version, and Tabular Editor 3, which is commercial version. But yeah, for most of your regular tasks, Tabular Editor 2, the free version, is totally fine. And with Tabular Editor 2, you can, if read write option on XML endpoint is enabled, you can also save changes. You can make changes to your semantic model and apply those changes back and deploy this model from Tabular Editor. You can deploy model directly to a workspace, of course, assuming that you have enough permissions to do that. And yes, creating reusable Power BI assets, I slightly mix the order of slides. So we are wrapping up this topic now of maintaining data analytics solution. So I will go back and say, when I was a Power BI beginner, that was my case. One of the first lessons I learned was how to connect and get the data from various data sources. Remember dashboard in a day and all this stuff, how to connect and get the data into Power BI. So think of SQL database, think of Excel files, and then so on. And you know what? I found myself very frequently in a position of creating the same or almost the same semantic model. It was called dataset back then, for many of my reports. So I would go and grab, I don't know, sales table, for example, product table and customer table. I had these tables in all of my reports. Now, if I had to repeat this tedious task each and every time, whenever I was creating a new report, I assume other people also had to do the same thing. Now, wouldn't it be great if we can somehow reuse this main set of data and then adjust it according to our specific needs? And that's where the concept of reusable data sets or reusable semantic model in this case kicks in. Basically, what is the idea? The idea is to create one main semantic model. Let's call it a golden data set or golden semantic model, and then enable multiple users to use this golden model as a starting point for building their reports. And it's not only about reusability. Once you confirm that data set or semantic model contains curated data, what you're doing, going back a few slides before, we can label this data set as promoted or certified so that others within the organization know that this semantic model was checked and confirmed for further usage. From there, you can open a new Power BI desktop file and use this data set as a source for your new report. I will show you this in a few seconds. Other than that, what you can do, you can also leverage Power BI template file. Essentially, when you're done with your work in Power BI desktop and you want to save it, instead of saving it as a regular PBIX file, you can choose to save it as a Power BI template, or PBIT abbreviated. The only difference between these two is that the template file doesn't contain any real data. It contains only metadata. So once you or someone else opens this PBIT file, they will need to refresh data in it to be able to see the real data in Power BI desktop. Then we have PBIDS, or PBI data source file, which includes all the connection details that are used in a specific file. And the purpose of this format is to quickly move connections from one solution to another. Usually, especially when you're building some complex reports, you have multiple connections within the file. And instead of going and opening and creating all these connections in a new PBIX file, you can simply take this PBIDS and export from PBIX and import this into your new file. And shared models, the concept that we already covered, where multiple users can leverage models that were already created. Now, of course, there are various permissions here that can be additionally that can be introduced to additionally control what happens and what are the rights for further usage of this data. So can modify, share onwards, and so on. I want to quickly show you just in how to use a shared semantic model. So I'm in Power BI desktop. I imported some data here, but let's just don't focus now on this. This will be used for later demos. So if I go here on the top and select Get Data, under Get Data, I have the option to use Power BI semantic models. So those are the models that someone already created, deployed to Power BI Workspace. And now, instead of going and creating the same model over and over again, I can simply click here, Power BI semantic models, and then all the models where I, as a user, have access right, can be used to build a report on top of it. Let's use something very simple. So I'll connect to this CMS import model. So now Power BI establishes a live connection to this semantic model. It will show me all the tables that currently exist. So I can define also, if I don't need all the tables, just some of them, let's say first three, or let's take this one and then submit. So it will allow me to connect to this model and then build a report on top of it. This report is so-called thin report because it doesn't contain its own semantic model. So it leverages another semantic model which is deployed in Power BI Workspace. We are just building a report without the model itself. And in case that I now build a report with you by using tables from this deployed semantic model and I click here on Publish button, this will publish report only. Usually when you import the data and you publish to a workspace, you get two items. You get report and you get semantic model. In this case, just report will be published, and this report in the background points to a shared semantic model. Okay? Good. We covered the first part. So we are ready for the biggest portion of this exam, which is prepare data. Let's do like a 15 minutes more of presentation, and then we'll do a short 5 to 10 minutes bio break for stretching legs and taking coffee or whatever. So yeah, let's jump into prepare data part. This one is the biggest one. And previously, query and analyze data was a subtopic on its own. Now it's incorporated into this prepare data. And now we have three huge subtopics within this big one: get data, transform data, and query and analyze. So let's start with get data. Obviously, the first thing we need to do when we start building our solutions is to create a data connection. Now, depending where your data is, there are different types of sources. Two main groups of data sources are cloud data sources and on-premises data sources. For cloud data sources like SharePoint, Dataverse, or Azure SQL DB, or ADLS, and so on, you can simply connect from your Fabric environment. You can simply connect to them. Obviously, again, you need to provide credentials and all the details for connecting to data source, but you don't need to introduce any additional components when you're connecting to cloud sources, which is not the case when you're connecting to on-premises data sources, such as CSV files, Excel files, SQL Server, I don't know, Oracle database, and so on. For on-premises data sources, to be able to connect to these data sources, you need another piece of software, which is called on-premises data gateway. It's free. You just need to download it, and you just need to keep it up to date, because it for all of you who work with Power BI, you're probably already familiar with on-premises data gateway. It's also being updated frequently, I think almost the same as Power BI desktop, so every month. Essentially, on-premises data sources, on-premises data gateway is a software that behaves as a bridge between your Fabric environment and your on-prem data sources. So it checks all the credentials, it checks all the queries, it passes the queries together with credentials, and then once the data is retrieved from on-prem data source, it's collected on a data gateway machine and pushed back to Fabric. So the main difference between creating a connection to cloud sources and on-prem data sources, with on-prem data sources, you need to have on-premises data gateway software installed. Now, how we can connect to world outside of Fabric? There are different options in Microsoft Fabric, and as soon as you start working with Fabric, or when you start learning about Fabric, you will realize that Fabric is all about the options. So one same thing can be done in multiple different ways. So almost every task, every operation can be done in multiple different ways. And it doesn't necessarily mean that one is better than the other. For some, of course, in some circumstances, we know which way to go, but sometimes it boils down just to your preference. And creating a data connection is not an exception. So we can create a connection to different data sources by using different items in Fabric. We will talk, in this session, we will talk about creating a data connection by using pipelines, by using data flows Gen 2, and by using Notebook. Of course, you see some other items. Mirror database is not part of DP-600, but I wanted to include just to give you a heads up that there are additional items in Fabric that can be used to create and establish data connection. Okay, when we talk about ingesting or accessing data in Microsoft Fabric, let's start with this high-level overview. This is, again, 10,000 feet high overview of Fabric platform in general. In the central part, this probably looks familiar. So we have one lake, we have different compute engines like Spark, T-SQL, KQL, and Analysis Services Engine, and we have different workloads or different experiences here at the top. This is a little bit outdated because there are no databases, but never mind. For what I want to explain here, it's absolutely enough. So this is core Fabric, let's say core Fabric. And when you ingest the data in Fabric, it will be ingested here within one lake physically. But then there are other options to bring data or to leverage data. Let's say not bring data, but leverage data from external services and external sources within Fabric the same way as they were natively stored in Fabric. It looks a little bit confusing, but let me explain one by one, and then you will understand for sure. So let's go from the left-hand side. We have this mirroring here on the left-hand side. Mirroring essentially allows you to establish connection to different non-Fabric data sources. Currently, again, as of today, we have 5 different data sources that are supported for mirroring feature. Azure SQL DB, Snowflake, Azure SQL Managed Instance, Azure Databricks, and Cosmos DB. So with mirroring, essentially, we are creating a replica of the data that exists in this system. We are creating near real-time replica within Fabric. In this case, with mirroring, we are creating a physical copy of the data. So when you mirror data from, let's say, Azure SQL DB in your Fabric environment, you will have a physical copy in near real time. You will have a physical copy of this data in Microsoft Fabric. That's how mirroring works. Open access APIs, let's keep this for a moment because, yeah, it's something that you probably won't use on a daily basis as an analytics engineer. Probably not, but yeah. I want to focus on this concept here at the bottom, which is called multi-cloud shortcuts. And this is one of the, in my opinion, this is one of the greatest features in the entire Fabric. So what shortcuts allow you to do is to create a virtual copy of the data in Fabric and use this data the same as it was stored in Fabric. Currently, from external data sources, you see what is supported: ADLS, Azure Data Lake Storage Gen 2, Amazon, Google Cloud Platform, and Dataverse. Now, let's go and talk about how all roads in Microsoft Fabric lead to, you know, this old saying, all roads lead to Rome. In Fabric case, this is not Rome, this is one lake. So all your data in the end ends up in one lake. That's why we said at the beginning, when we're discussing the overall architecture of Fabric, that one lake is the central storage repository for all the data that you plan to use within the organization. So no more data silos. I store a part of my data here, part of my data there, then I need to integrate this and so on. Here, the idea is that all the data is available directly from one lake, either physically stored in one lake or either through some data virtualization, which is achieved, for example, by these shortcuts. So essentially what shortcuts are. You know shortcuts, of course, you all know shortcuts in Windows File Explorer. We all have some Word document or any other document stored somewhere on our D drive under the series of subfolders. And instead of each and every time going to this subfolder, we create a shortcut on our desktop and we double click and we access the content of this file, right? So that's how shortcuts work in Windows File Explorer. It's very similar in Fabric. So the concept is very similar. So again, your data, think of this in terms of analogy. I talk about the file. Now the data lives somewhere else. And when I say somewhere else, I'll explain where this somewhere else can be. So data lives somewhere else. But by creating shortcut, we can leverage this data as it was natively stored within Fabric. So it's a pointer to data that is stored somewhere else. And then when we need it for combining with data that is already stored in our Fabric environment, we can simply pull the data directly from its original location, from its data source. Now, there are two types of shortcuts in Fabric: internal and external. Internal shortcuts point to another Fabric items. I will explain this and show you in a demo what I'm talking about. So when we talk about internal shortcuts, we are talking about leveraging data from other Fabric items. And when we talk about external shortcuts, those are systems that are external to Fabric, like ADLS Gen 2 or Amazon S3 or Dataverse, Google Cloud Platform, and so on. How shortcuts work? Let's say I have workspace A, and I have two lakehouses in this workspace. I have lakehouse A and I have lakehouse B. And I have some tables in my lakehouse A, I have some tables in my lakehouse B. So what I can do here is I can create a shortcut to a lakehouse B and use a shortcutted version of this table B within my lakehouse A. You will recognize this by this, there is the icon, like a chain icon, that shows that a specific table is in fact a shortcut to some other data destination. So I can use this delta table the same way as I can use those two which are natively stored in my Lakehouse A. That's a scenario with one workspace. What if I have another workspace B, and I have Lakehouse C and table C? Again, so I can do a cross workspace shortcut. And if I have a proper access, obviously, to Lakehouse C in this workspace B, I can create a shortcut to table C. And then I can leverage all these 4 tables like they were natively stored within my Lakehouse A. So physically, data stays in its original location. It's a pointer. And then when I create my queries, this data will be loaded here and used for those queries. Let's go to Fabric and create shortcut just to show you this in action. So I'm currently on the home page of my Microsoft Fabric, and then let's go to data engineering, and let's open this DP-600 bootcamp. So as you see, I currently have different Fabric items in this workspace. I have a lake house, I have a warehouse, event house. We will talk about that later. And for example, let's say I want to create some shortcuts in my DP-600 bootcamp lake house. As you see, I have some tables that I already loaded here. So all of those tables are physically ingested and loaded into Lakehouse DP-600 bootcamp. I can simply click on 3 dots and say new shortcut. This will launch the wizard, and these are the things that I mentioned: internal sources, external sources. So you see what is currently supported. Again, things are changing in this area as well. So probably we will have shortcuts supported for other systems in the future. But let's keep it simple here. I'll go to another lake house. Let's take this one, DP-600 LH, which is in a different workspace. So this one is in DP-600 playground workspace. And from here, I can choose tables and files that I want to, where I want to create shortcuts. Let's say I need this Contoso 2 tables, dim currency, dim customer. So I click next and then create. And then after a few seconds, these 2 tables are here. You see the small chain icon in the top left corner. This means that this table is a shortcut. And basically, this one points to a location that is outside of this lake house. So it's a different lake house, different workspace. But from here, I can combine this data with my existing delta tables in this lake house, the same way as this data was natively stored here. So the concept of shortcuts is super, super powerful and really enables you to push the limits when it comes to combining data without necessarily physically moving it from one place to another. Okay, I suggest we do a short break of like, I don't know, 10 minutes, and then we jump into pipelines. So yeah, stretch your legs, refresh, and see you in. Hello, and welcome back. Hope you used these 10 minutes to properly refresh your brains and that you are ready for more Fabric and DP-600 goodies. So yeah, let's proceed with pipelines. Uh, Pipelines in Microsoft Fabric encapsulate a sequence of activities that perform data movement and processing tasks. You can use a pipeline to define data transfer and transformation activities and orchestrate these activities through control flow activities that manage branching, looping, and other typical processing logic. Before we proceed, thanks, Martin. Thanks for donation. I really appreciate that. Thank you. The graphical pipeline canvas in the Fabric user interface enables you to build complex pipelines with minimal or no coding required. Now, activities, that's the key concept in pipelines, and activities are essentially the tasks that we are executing in a pipeline. You can define a flow of activities by connecting them in a sequence, and the outcome of particular activities like success or failure or completion can be used to direct the flow to the next activity in the sequence. There are two broad categories of activity in a pipeline: data transformation activities. So those are the activities that encapsulate data transfer operations, including simple copy data activities that extract data from source and load it to a destination, as I will show in a few minutes, as well as more complex data flow activities that encapsulates data flows Gen 2 and that apply sometimes complex transformations to the data as it is transferred from the source uh, to Fabric. And also we have control flow activities. Those are the activities that you can use to implement loops, conditional branching, or manage variable and parameter values. Since I mentioned parameters, they are also available in Fabric pipelines. And finally, you can schedule, so you can, with parameters, I forgot to mention this, you can parameterize different properties in pipelines and activities. And also you can schedule runs of Fabric pipelines. Obviously, it's not a good idea to go, I don't know, every 1 hour and clicking manually to execute the pipeline. You want to schedule the run, and depending on your business needs, you can schedule pipeline run to run, I don't know, every 10 minutes, every 30 minutes, and whatsoever, or once per day, and so on. So some of the common activities in a pipeline, first and most important, is copy data. That's one of the most common use cases of data pipeline, and many pipelines consist just of a single copy data activity that is used to ingest data from an external source into Fabric Lakehouse and bring this data in. So the copy data tool that is very intuitive and straightforward way. So when you add a copy data activity to a pipeline, this graphical tool will walk you through all the steps required to configure the data source and destination for the copy operation. Wide range of source connections are supported, making it possible to ingest data from most common data sources. Before we move on to data flows, I just want to show you how easy it is to create a pipeline in Microsoft Fabric. So I'll go to my DP-600 bootcamp, and here at the top, I'll select new item, and then here it is, data pipeline. It's here. So I'll click on pipeline. Let's call this one pipeline live stream DP-600, and I'll click on create. So when you create a new pipeline, it's just a shell. It doesn't contain anything. It doesn't do anything. You need to provide certain activities to be able to get something out of this pipeline. And this is what I mentioned. You have a copy data assistant. So if I click on copy data assistant, this will walk me through all the steps necessary to bring the data from external data source into Microsoft Fabric. Also, I can bring from another Fabric item, so I can bring data from another lakehouse or warehouse into different lakehouse. But in this case, let's connect to a SQL Server database. So I'll provide the name of my local instance of SQL Server, and let's connect to AdventureWorks database, since I already created this connection previously. And when we talk about connections, remember, in this case, because I'm connecting to a SQL server, this is on-prem data source, I need on-premises data gateway installed on this machine, which I obviously have. So I will now connect to my AdventureWorks database. And then from here, I can write queries if I want. So I can combine data from multiple tables, use a query, and bring this data in a form of Delta table into Fabric. Or I can simply go and choose between tables that already exist here. Let's keep it simple. I take this dim employee, for example, just a single one. So essentially, copy data is a fairly straightforward tool, low code, no code approach that allows you to bring data quickly into Microsoft Fabric. So now I can choose to create a new lakehouse, but in this case, I want to use the existing one. So I'll use this DP-600 bootcamp. I can choose to store this table in files or tables area. We will examine what is the difference between files and tables area later. Loading to existing table or loading to a new table. So let's load to a new table. And now this this copy data assistant will try to figure out what are the proper data types, because not all data types that exist in certain data sources are supported in Fabric. So for example, there is no nvarchar in Spark, so this will be translated internally to string data type for Spark, but don't bother too much yourself with it. Let's keep it simple, and then let's click on next, and then save and run. So now I have my pipeline. Either although it's super simple, I have just one single activity, and that is copy data. Here in the bottom, I can configure different properties like source, so I can parameterize this, destination, I can remap in different way, change data types, and so on. And automatically, once you create this pipeline, this one will execute and run automatically. What I mentioned previously, here under run, you can schedule the run of this pipeline, or you can run it manually. You always get the message with information if the pipeline was successfully executed or not. So under the run tab here on the top, you can choose to manually execute the pipeline, or you can schedule it. Under activities, you see a whole bunch of different activities that you can use. So let's say that, for example, once my data is in the lakehouse, I want to perform certain transformations by using notebooks. So once this is successfully completed, so on success, it can be also a question on DP-600, what is the difference between on success and on completion? On completion doesn't take into account if this specific activity was successfully executed or not. It's just completed. Successfully or unsuccessfully, it's completed. And then for this, you need to define what happens there. Thanks, Thomas, for the donation. Really appreciate. Thank you. And once this is successfully completed within this notebook, of course, now I still don't have a notebook, but then I can schedule the notebook to run, to do some data transformations, maybe to load the data into some other table or some other lakehouse and so on. I can also control with if conditions. So for those of you who are old enough, and I know that there are some people here who are old enough, like me, if you remember, I wouldn't say Azure Data Factory because it's not old enough, but if you remember SSIS, or how was the tool called before SSIS? It's on top of my tongue, but I can't remember. DTS, it was abbreviation. Never mind. I'm too old, so I keep forgetting things. So essentially, if you work with all these data orchestration tools from Microsoft or from other vendors, you will feel very comfortable here within Fabric pipelines. If you're not sure, DTS, it's data transformation service or something like this. I forgot, but it was DTS. Not sure if if we have some older people here who remember that, that was really before SSIS. Okay, never mind. I will find it during the next break. So here under 3 dots, you can see all the activities that are available. And one of my favorites is semantic model refresh, meaning previously we had to do some gymnastics and I don't know what kind of different things to figure out where when our ETL process is finished, we want to refresh our semantic model as the last step of this ETL pipeline. Basically, now you don't have to figure it out on your own, so you can simply add at the end of your pipeline, you can add this activity semantic model refresh. You define which semantic model you want to refresh, and once the entire process is completed, you refresh your semantic model, and your end users will be happy to have the latest data available in their Power BI reports. So this is really how simple and easy it is to use pipelines. Of course, in reality, you may want to introduce more complex solutions, and usually you want to build maybe something that is more metadata driven than just hard coding certain values and so on. But from a perspective of a beginner and of someone who wants to pass DP-600, this is enough to know. So yeah, that's where I stop regarding pipelines. Data transformation services. Yes, so I'm not completely lost. So yeah, thanks David for bringing this. Yeah. Okay, so let's move on to the next feature or next service that we can use to ingest the data into Fabric, and this is Data Flows Gen 2. Data Flows Gen 2 allows you to leverage low-code interface and more than 300 different data and AI-based transformations, letting you transform data very easily and with more flexibility than any other tool. So what is a data flow? Data flow is a type of cloud-based ETL or extract, transform, load for those of you who are not familiar with this term, for building and executing scalable data transformation processes. So data flows allow you to extract data from various sources, transform it using a wide range of transformation operations, and load it into a destination. I will do a small digression and compare data flows Gen 2 with data flows. Let's call them data flows Gen 1. Those are data flows that exist in Power BI world since 2018 approximately. So this is from a user interface perspective, this is the same thing. You have this familiar Power Query online experience. You do your transformations by clicky, draggy, droppy actions. So no code is required. Of course, if you want to write M code, be my guest, but you are not required to do that. So you can do everything from a user interface. And similarities between data flows Gen 2 and Gen 1 finish there. The engine is different, but the most important difference is that with data flows Gen 1, so with the old one, once you connect to a data source, do a transformation and everything else, you store this as an artifact called data flow within a workspace. And then only Power BI items can leverage data from this data flow. You connect to a data flow from Power BI desktop, you build your report, and you publish your report. So data flow is your data source. Now you can do the same thing, connect to a data source, perform transformations, but now you can output results of those transformations into your Fabric lakehouse or warehouse. There are also other destinations outside of Fabric that are supported, but for us as Fabric analytics engineers, we care about destinations in Microsoft Fabric. So you can output transformed data into a lakehouse or warehouse in Delta format, which means any engine that can read Delta format, talking about SQL engine, Spark engine, analysis services engine. So all the engines within Microsoft Fabric, as well as outside engines that can read Delta, can consume data that you just transformed. That's a huge difference compared to data flows Gen 1. Again, data flow can be considered as a standalone item in Fabric world. So once you create a data flow, it will appear as an item in a workspace. And you can run it independently, but it can be also run as an activity in a pipeline. Just to show you, if we go back to my pipeline that I previously created, there is a data flow activity. So I can say, yes, okay, once I loaded the data, let me delete this. Once I loaded the data with copy data activity, because yeah, I don't know Spark, I don't want to use Notebook. Yeah, I know Power Query, I'm good with Power Query. I do all the things in data flow. So once this data comes into my Fabric workspace, into my Fabric Lakehouse, sorry, I will use data flow to connect to this data from a lakehouse, do some additional transformations, do whatever I need, and then again I can output it somewhere else. For example, I can transform the data and output it in a warehouse and use warehouse as my final layer for business reporting. So data flow can really be executed both as a standalone artifact and as a part of the orchestration process within the pipeline. And this is important. This slide, please, this is important, especially for DP-600, because there will be certain questions which will ask you to perform operation X, operation Y, and so on. And depending on the requirements in the question, you need to choose between a pipeline or a data flow. Okay, so this is important to understand what are the differences between data flows Gen 2 and the pipeline, because people sometimes mix those two things. When you need to perform data transformations beyond some light data transformations, talking about light data transformation that you can do in pipeline, within the copy activity, you can change the column type, you can exclude some columns from loading, but you can't really do any, let's say, real data transformations. You can't replace values. You can't I don't know, add new columns and so on and so on. So for that, for data transformation purposes, you're using data flows. You can't really do a proper data transformation with the pipeline itself. Okay, so we need to use data flows for that purpose. For data profiling, so this great feature within Power Query and also in data flows Gen 1, when you go to view and then turn on this column profile, column quality, and column distribution, whenever you need to perform data profiling operations, data flows. You can't do that in pipeline. Again, if you are a user that is familiar already with Power Query and that experience environment, you know how to leverage Power Query to achieve your business goal, then data flows Gen 2. And in terms of number of connectors, data flows support many more connections out of the box compared to pipeline. So currently there are more than 150 connectors that you can use out of the box with data flow. Pipeline is predominantly used for orchestration, meaning, yes, I can create a pipeline that just contains of one single copy data activity. That's not an orchestration, okay? So that's just ingesting data from point A to point B in Fabric. That's not orchestration. But whenever you need to include multiple different activities and define some logic between those activities, like when activity A completes, I want to perform activity B, and so on, we use pipelines. So you can't orchestrate data with data flow, right? It's a task for pipelines. Whenever you need these simple lightweight transformations with copy data, it's usually much faster than data flows Gen 2. So it's usually faster. And again, data flow can be part of the orchestration process. So data flow Gen 2 can be part of pipeline, but not the other way around. So pipeline cannot be part of data flow Gen 2. Hopefully this clears the picture a little bit. But we have more things to consider and to choose between in Fabric. Remember, Fabric is all about the options. Yes, that's right. So now Lakehouse, Warehouse, or Event House. When to choose what? Let's start with Event House. And whenever we talk about Event House, about KQL stuff, whatever has KQL in its name, its main purpose is for handling streaming data. Yes, you can handle other types of data as well with KQL and with KQL database and so on. Yes, you can, but the main purpose is to handle streaming data. So data that comes in real time, you want as soon as data is coming, you want it stored somewhere within the fabric. And for that purpose, we are using event houses and KQL databases. So event house as an event house, it's an item in fabric, but it doesn't really do anything. So it's kind of a container for KQL databases. The purpose is to provide a unified monitoring and management across multiple KQL databases. And as soon as you store the data in event house in KQL database, it's automatically indexed and partitioned. So this is how this architecture looks from a high level perspective. We have a workspace and we have, let's say, event house A and we have event house B. And then we can have one or multiple KQL databases within each of the event houses. So event house, again, it's not the artifact that stores the data. It's a container for KQL databases and other KQL related items. We will also examine some of them throughout the session. That's event house. We have more houses in Fabric. We have, and those two, let's be honest, will be predominantly used. So lake house and warehouse. So we have a data lake house and data warehouse. What's the difference between these two? First and foremost, the foundation of Microsoft Fabric as a platform is a lake house, which is built on top of one lake storage layer that we already examined. And Lakehouse, in this sense, is a unified platform that combines flexible and scalable storage of data lake and the ability to query and analyze the data of a data warehouse. So pioneers for this term Lakehouse is Databricks. And since this term was introduced a few years ago, now it's generally accepted and everyone talks about data lakehouse. So essentially, Lakehouse presents a database that is built on top of data lake using Delta format tables. And Lakehouses combine SQL-based analytical capabilities of relational data warehouse and this scalability and flexibility of data lake to store literally whatever you want. Lakehouses store all data formats and can be used with different analytic tools and different programming languages. And as cloud-based solutions, Lakehouses can scale automatically and provide high availability and disaster recovery. Some of the benefits of Lakehouse, so they utilize both Spark and SQL engines. We will understand to what extent they utilize SQL engine. But both Spark and SQL engine can be leveraged within a Fabric Lakehouse. They adopt a schema on read format, which allow flexible schema definition as needed, rather than relying on a predefined schema. And then they support this ACID type of transactions through Delta Lake tables, ensuring data consistency and data integrity. This is a lakehouse. In Lakehouse, we can store any type of data, meaning video files, images, JSON files, all the way to Delta format, which is considered as structured data. So we can store structured, unstructured, semi-structured data in a lakehouse. Whereas in a warehouse, it's more similar to traditional data warehousing workloads that we know for decades. So it relies on relational schema modeling, and it allows for storing structured data. So you can't really store, I mean, in theory you can, but we are not using data warehouse to store images and so on. It's not built for that. Okay, let's put it that way. So when you create a lakehouse in your Fabric workspace, once you click create lakehouse, you will get 2 additional items automatically created for you: SQL Analytics endpoint and default semantic model. Now let's examine what we have within each of these. In a lakehouse itself, we have two areas. I briefly mentioned them when I was creating a shortcut. We have files area and we have tables area. Files area is an unmanaged area, so it's not managed by the Spark engine, and you can literally store whatever you want in this files area, all the way from CSV, JSONs, images, whatever, PDFs, whatever. And then we have a tables area, which is managed by Spark. In theory, you can store CSV file in your tables area, but in Fabric, you don't really want to do this because this can be leveraged further by other experiences in Fabric. And the overall idea of Fabric is have one copy of the data that can be leveraged across multiple different workloads. So that's why I mentioned preferably Delta. Technically, you can store different things, but you really want Delta format stored in tables area. Just to go back and quickly show you what I'm talking about, let me duplicate this. Thank you, Matthew. Thanks for donation. Thank you. Thanks so much. Oh, greetings to Dragan. Thank you. Thank you. Thank you, guys. Okay, so if I open my Lakehouse, and oops, here on the left-hand side, you see I have files and I have tables. So under files, if I click on files, I have 3 CSV files. So I can store whatever I want here, basically in this files area. And in tables area, I only have, let me just refresh this. I'm a little bit annoyed when I have something in this unidentified. Here I have just Delta tables. So this is tables area. This is how Lakehouse look like. And going back to my workspace, this is what I wanted to show you as well. I have 2 additional items here. I have SQL Analytics endpoint and I have default semantic model. So let's go back to slides and just explain what these 2 are. So SQL Analytics endpoint is something that Lakehouse exposes. So you can use T-SQL language, well-known T-SQL language, to query the data from the Lakehouse. And when I say query the data, that means it doesn't allow you to perform operations that will change the data in a Lakehouse. So you can't do updates, deletes, inserts, and so on. So you can really just query the data using T-SQL. Of course, you can do some administrative stuff, grant roles, permissions, and so on. But you can't change the data. You can create store procedures, you can create views, as long as they don't manipulate the data in terms that data will be changed in a Lakehouse. Through this SQL Analytics endpoint, only Delta tables will be exposed. And that's what I mentioned previously. If you have a different format stored in a tables area, this one is not queryable by using T-SQL. So this will not be included in SQL Analytics endpoint at all. So only Delta format will be included in SQL Analytics endpoint. And the key, let's say the key use case for SQL Analytics endpoint, aside from this possibility to query it by using T-SQL, is for direct lake storage mode. When you build a semantic model which uses direct lake storage mode, and for all the queries that cannot use direct lake, we will talk about that later, they will automatically fall back to direct query mode, and then data comes through this SQL Analytics endpoint. And we have a default semantic model. We will talk about that later in this part when we talk about Power BI in Microsoft Fabric. What are the tools and techniques to explore and transform data in a Lakehouse? So there are multiple of them. The main way of doing things in Microsoft in Fabric Lakehouse is using Apache Spark. That's a native engine that works with Lakehouse in Microsoft Fabric. Within Spark engine, within Spark experience, we can use notebooks or Spark job definitions to explore and transform data. Of course, we have SQL Analytics endpoint, as I said, as a read-only point for querying the data using T-SQL language. We can use data flows. Previously, we examined data flows. So with data flows, we can transform data in a Lakehouse. With data pipelines, we can ingest the data, we can move it from there, And finally, we can visualize it with Power BI. Let's talk about notebooks. I'm not a Python guy, but I find notebooks really one of the coolest feature. I met them first time, to be honest, with Fabric. I never used notebooks in my previous life before Fabric, but now I'm becoming more and more fan of it. And my friend Tom Martens, who is also here, I know he's even bigger fan than me of notebooks, and he's always trying to convince me that I should use notebooks more and that I should use MacBook, but yeah, I don't take that. Okay, so in Fabric notebooks, we can use different programming languages. So default language is PySpark, but you can also use Scala, R, or Spark SQL. Since recently, I think like 2 weeks ago, we can use Python itself. We can also write T-SQL language within the notebook, execute it from a notebook cell. But again, it's just for reading the data. We can write Markdown. We can use Markdown to write comments. This is one of my favorite features because, yeah, I create something and then after 3 or 4 weeks, I come back and then I can't figure out what I did. So this feature for writing comments in Markdown, that's lifesaver for me. Running on or freezing individual or multiple cells and using notebooks to ingest and transform data as well. Notebooks support automation, so you can schedule the run of the notebook either as a separate item, either through orchestration process within the pipeline. So notebooks, same as data flows, can be scheduled to run outside of pipeline or as a part of wider orchestration process. Okay, let's talk about warehouse. That's another option for storing the data. So same as Lakehouse, it's centered on a single data lake. So storage layer for a warehouse is still one lake, same as for a lakehouse. It's powered by Synapse Analytics. And when I say powered by Synapse Analytics, that means the same engine, which is called Polaris, that was introduced with Azure Synapse Analytics. That's the engine behind Fabric Warehouse. Fully or almost fully supports T-SQL. Let's say 98% of things that you can do in traditional T-SQL workloads, meaning SQL Server, Azure SQL DB, and so on, can be done in a warehouse. But there are certain features that are obviously outside of the scope of this session today that are not supported or not supported yet. We'll see. But think of it that it almost fully supports T-SQL that we know. And it stores data in Parquet file format or Delta file format in the end. Tools and techniques to explore and transform data. In this case, SQL endpoint of the Fabric warehouse, which is built in the warehouse. So when you create a warehouse, you don't get a separate artifact, which is SQL Analytics endpoint. Just to show you, if I go here, here is my warehouse. And I don't have a SQL Analytics endpoint. I just have a default Power BI semantic model. So there is no separate artifact because SQL Analytics endpoint is built in a Fabric warehouse. And this version here, it's both read and write, so you can update, delete, and insert data through the SQL endpoint. Again, using data flows Gen 2 or data pipelines to ingest or transform data, and again, visualizing with Power BI using direct lake mode or any other of existing modes. So to recap, if you are coming from a SQL background like me, there are two types of SQL houses in Fabric. SQL endpoint of the Lakehouse, and it's not called Synapse Data Warehouse anymore. Apologize for that. I need to update this slide, so it's just a warehouse now. So this one, SQL endpoint of the Lakehouse, it's automatically generated, supports only read operations. Please keep in mind that if you have a question on DP-600, you need to do X, Y, Z on a Lakehouse, and you need to choose if you do that with a notebook or writing T-SQL store procedure. You can't really do that with T-SQL store procedure, right? So you can use procedure, but you cannot change data in Lakehouse by using SQL store procedure. Whereas in warehouse, as we already mentioned, it's more like traditional data warehousing workloads where you can do all of this stuff using T-SQL. Just to make sure, because that's, from my experience, what I heard from people teaching them Fabric in previous months, is they think, okay, Lakehouse stores the data in format, delta format. Warehouse stores in some other format. Everything is in one lake. But in the end, those are just files. So those are just bunch of Parquet files with delta log as a layer on top of that provides metadata information about those files. But both Lakehouse and Warehouse, they store the data in the same format, absolutely the same format. It's just which engine you are using to process the data. When you store the data in a Lakehouse, you are using Spark engine and you are using notebooks to process the data. When you store the data in a warehouse, you are using Polaris engine and you are writing T-SQL code to process the data. That's the only difference. From storage perspective, it's the same. There is no difference. Okay, moving on to the next topic. One of the features that was also recently introduced is one lake integration for semantic models and warehouses. And I think this is very useful feature. We'll see how it's going to work in real life, but from a conceptual point of view, it's really cool. We have different data sources. You see here on the left-hand side, I have Excel file, SQL database, SharePoint, whatever. And essentially, I bring this data into Power BI semantic model. So we create our Power BI semantic model like we did in previous 10 years. We combine this data, mesh this data, we create semantic model in import storage mode. And this semantic model consists of 1, 2, 3, 5, or 100 tables. Now, wouldn't it be cool if we can somehow reuse these tables somewhere else? So it's not locked within the Power BI semantic model. And that's where this feature kicks in, this integration for semantic models. With one lake integration, all these tables from your import semantic model will be created and included in one lake in the format of delta tables. So I have 50 different tables in my import mode model. I will have 50 tables, 50 delta tables in one lake. And from there, since you already learned that all the engines can read delta within Fabric, from there, once I have this in my one lake as a delta format, I can write notebook to query this data. I can use warehouse to write T-SQL to query this data. I can create direct lake model on top of these tables and have a brand new semantic model that uses direct lake storage mode. So the idea is to enable this reusability to have this data not locked in here, but available also for other experiences in Microsoft Fabric. This feature is, I'm not 100% sure, so please take this with a grain of salt. I think this feature is by default it's disabled, but it's disabled, so you need to explicitly enable this feature to toggle on this one lake integration option. And this can be done in two different places. So here under settings for the model and within Fabric tenant. So here when it says semantic models can export data to one lake. And this one, users can store semantic model tables in one lake. For Event House, it's similar. I mean, conceptually is the same again because as we already learned, KQL databases are not storing data in delta format. It's a different format, but sometimes you want to leverage this data also and combine it with data that is stored in a lakehouse or warehouse. And basically, it's not so easy to do. And by turning on a one lake integration for Event House, this data will be available in delta format also in one lake. You can choose to do this on the entire KQL database level. If you turn it on the entire database level, obviously the entire database will be integrated into one lake, or choose just specific tables that you need. We are done with the first part, get data. Let's move on to transform data. Still a lot of things to cover. Okay, so first, before we jump into creating views, store procedures, let's first understand, because we want to transform data uh, using certain features or services in Fabric. Let's first understand, take one step back and understand how to organize data in a lakehouse. Lakehouse is the architecture of choice in Microsoft Fabric. And although Microsoft makes a distinction between the lakehouse and warehouse, as you already learned in the previous part, this separation in the end might introduce some confusion, especially for new Fabric users. Uh, Let me try quickly to explain why. In today's cloud analytical landscape, we have a separation between the storage and compute. So if we talk about storage, data lakehouse means that data is stored as files in the lake, in this ACID compliant Delta Lake format. And then you choose between different engines like Spark or SQL engine and so on to process files in the storage. And in Microsoft Fabric, the storage layer is lake. To be more precise, one lake which we previously examined. So don't be baffled, don't be confused when you hear data warehouse. Don't think about some proprietary formats in the background like we had before Fabric. It's still lake. It's still lake. It's just a different engine, as we already explained. So let's now try to explain this way of organizing data in a lakehouse. The most common pattern for modeling data in a lakehouse is called medallion. A lot of people call this architecture. I wouldn't call it architecture. Let's say data modeling approach. Architecture is, I think it's something different, but that's my opinion. Sorry for that. Why it's called medallion? The same as for the lakehouse concepts in general, credit for being pioneers in medallion approach goes to Databricks. And simply said, medallion architecture assumes that your data within the lakehouse will be organized in 3 different layers: bronze, silver, and gold. That's why it's called a medallion. Now you may also hear terms such as raw, validated, enriched, or curated, which I personally prefer. But essentially the idea is the same: to have different logical layers of data in the lakehouse that are of different quality and serve different purposes. So call it however you want, but medallion architecture is generally accepted term. So therefore I will refer from now on, I will refer to this data modeling approach as medallion. Let's quickly examine all these 3 layers. And what I also wanted to say, there is a great video, I think Simon Whiteley from Advancing Analytics did this, explaining basically how you can customize this medallion architecture. It doesn't necessarily need to be 3 layers. You can have 1, 2, 5, 10. So it's just up to you to define what you consider the next level of data quality, and use that as multiple layer structure. But let's stick with the naming conventions and the approach that is relevant for DP-600. Okay, the digression from previous 5 minutes was more my, not rant, but it's more like in real life you will probably see different things. Okay, going back to bronze layer. Bronze layer is where we land the data from external sources in its raw state, and data is ingested as is, containing only metadata in addition. The purpose of the bronze layer is to serve as a repository of the historical archive of source data and enable quick data reprocessing when necessary, without need to connect to a bunch of external systems again. It's important to keep in mind that bronze layer contains unvalidated data. In regards to storage format, the bronze layer usually stores the data in one of the in its original format, whatever it is. I don't know, CSV, JSON, whatever. Usually we store the data in its original form, in its original format. Then let's move on to silver layer. In the silver layer, data from the bronze layer is conformed and cleaned so that all the key business entities, concepts, and transactions are available in the form of a so-called enterprise view, which is ready for ad hoc analysis, ready for machine learning workloads. That means the data is enriched and validated, and from that point, it can be trusted downstream for further analytical workloads. From a data modeling perspective, usually silver layer contains more third normal form like tables. So usually, again, this is not set in stone, but usually it's more like third database, which is operational database normalized to a third normal form. And in the silver layer, data should already be stored in some of more performant formats, such as Delta or possibly Parquet. And finally, we have a gold layer. That's the icing on the cake in this approach, where data is structured and organized to support specific project requirements. Because this is the final stage in the entire process, data is additionally refined and cleaned. And in the gold layer, we also apply various complex business rules, business logic, use case specific calculations, and so on. From the data modeling perspective, again, usually doesn't necessarily mean that it should be always like this, but it's usually implemented through a Kimball style star schema where the data is denormalized to support business reporting requirements. In terms of storage, data should be stored definitely here in Delta, unless you really have a good reason not to do that, but should be stored in Delta. Moving data across medallion layers refines, organizes, and prepares it for downstream data activities. And within Fabric's Lakehouse, there is, as you've already learned previously, there is more than one way to move data between layers. There are a few things to consider when deciding how to move and how to transform data across those layers. How much data are you working with? How complex are transformations that you need to perform? How often will you need to move data between the layers? And last but definitely not least, what tools are you most comfortable with? If you don't know PySpark or T-SQL, and you don't want to burn your chat GPT, then you probably want to use data flows. So it also depends which tools are you and technologies are you most comfortable with. Fine, let's move on to creating views, functions, and store procedures. In the warehouse, it's the most straightforward, the same as in traditional T-SQL workloads. So you can create views, functions, and store procedures. In Lakehouse, you can do that with PySpark or Spark SQL, or you can do with T-SQL, but only those objects that just read the data. Remember, it's read only through the T-SQL analytics endpoint. So views, functions, store procedures that read the data can be created using T-SQL language. In Event House, we are using KQL, which stands for Custo Querying Language. That's a special, it's a different language than other querying languages, although similar to some, and we will see some examples in the next slides. So for querying KQL databases, we are using Custo Querying Language. The main difference between an event house, or let's say KQL database, and warehouses and lakehouses is that you can create materialized views in KQL database, and you can't do that. It is still not supported in lakehouse and warehouse. It's coming, but it's still not supported. Keep in mind, if you work and if you rely on building your and implementing your logic in database views, a lot of us used to do that in traditional SQL Server workloads, building entire layers using views. If you create views in a warehouse or lakehouse, they will not work with direct lake mode. So direct lake mode, when you use views, will automatically fall back to direct query then. Let's see how to enrich data by adding new columns and new tables. So in a lakehouse, we use notebooks or Spark jobs for data transformation, and we usually operate on a data frame level. So data frame is an object that exists or structure that exists in PySpark. I like to think about it as a temporary table in T-SQL because, as I said, I'm coming from T-SQL background. Maybe I'm wrong, but that's how I think about data frames. So I do different things on this data frame, and finally, when I'm ready, I drop this data, I push this data into a real table. with with column and select functions, we can create new columns and tables. So this is a very, very simple example. Let me go here just to zoom it a little bit. With column function or method, that's method, sorry, method to apply on a data frame. So df stands for a data frame. With column will add a new column in case that the column with the same name doesn't exist already in the data frame. If the column with the same name already exists, it will simply overwrite the existing column. If not, it adds a new column. In this case, because I don't have those columns first and last in my data frame, this will create two new columns, two additional columns. Okay. In a warehouse, and thanks to Andy Cutler, my friend, I know you're here, so thanks for the great blog post you wrote about this. In warehouse, this is one of the things. You remember I mentioned that 98% of traditional T-SQL operations are supported in Fabric Warehouse. This one goes into those 2% that is not supported. So alter table add column is supported, so you can add a new column. But once you add a column and you have it in a table, if you try to alter the column, which works as a charm outside of Fabric Warehouse, here it doesn't work. You will get an error. Also, alter table drop column also doesn't work. It's not supported yet. We'll see. Add column was also not supported up until a few months ago. It now works. So if you want to add a table, add a column to a table, this operation here, alter table dim product, add column name and data type, this one should work. But altering existing column and dropping column does not work. In KQL, in Custo database, dot alter table command is supported, and when you use this function, please keep in mind that existing non-specified columns will be dropped. So if you want just to include new columns, you need to specify all the columns that are part of the table already. Therefore, first use dot show table CSL schema to get the existing table schema before you change it. So you see what columns are already included, and once you add the column, it adds a nullable column to the end of the schema. This is a simple example of how you add a new column in KQL database. So alter table and then adding the column. In KQL, we are still in KQL databases. There are many operators that don't exist in SQL. For example, extend operator, which creates a calculated column and appends to the end of the result set. So in this example here, I have two columns, end time and start time, and I'm adding a new column, new calculated column at the end of this table, which will calculate the difference between end time and start time value. So with the extend operator, we are creating calculating column and appending it to the end of the result set. Great. Let's move on to star schema. I see a lot of you in audience that I know are huge fans of Kimball, and yeah, this one is for you. So how to implement star schema for a lake house? Let's first quickly explain, because I'm not 100% sure that all of you understand what star schema is. So as per Kimball, a guy who wrote a book in 1995, I think, or introduced his principles of dimensional modeling. So Kimball says that in data model, each table should be classified either as a fact or dimension table. So we have a distinction between fact tables and dimension tables. Dimension tables are, so dimension is a rough name. So really it doesn't explain what these tables are doing. Therefore, I like to refer to them as lookup tables. So essentially I need an information about something, and then I go to lookup table and find this information, like description or many other different attributes that can describe certain thing. I find this in dimension tables, and they usually answer the question starting with W. So who bought something? When did they bought? When did they buy? Where? who, who, when, where, why, what. So that's how I think about dimension tables. And then we have fact tables that store some data about some events. So something that happened. This can be a transaction on the terminal in your local supermarket. This can be information about the temperature for today in Salzburg or somewhere else. So any event, anything that happened at a certain point in time in certain location and so on, it's stored in a fact table. And fact table usually contains only those numeric values plus information about key columns that we can use to refer and pick up the data from these lookup tables or dimension tables. Within the dimensional model, we have few more concepts to understand. One is about creating unique keys. And there are two different types of keys in dimensional modeling, so-called surrogate key and alternate key. So surrogate key is a dummy, meaningless integer or any other whole number value that we use to uniquely identify a record in a table. Why are we using surrogate keys and not alternate keys? Alternate key is the key unique identifier from the source system, because it can happen that you are loading the data into your warehouse from multiple different source systems, and it can happen that you have a business key in each of these systems, and there is the same value for this key in system A and in system B. So how you differentiate in your warehouse between these two? You need to add this surrogate key, which will basically serve the purpose of being this unique identifier. So that's the difference between surrogate key and alternate key. You will also hear term business key for alternate key, but surrogate key is surrogate key, just a dummy integer value that linearly increases by one and uniquely identifies the record in a table. Some more concepts that are relevant for star schema. Snowflake schema is another concept in dimensional modeling. It's a star schema which is further normalized, and we are talking about normalizing dimension tables. So in this case, you see that I have a dim customer table, which is further normalized to dim geography and dim store. So more granular dimensions, more dimensions that remind of modeling the data in traditional transactional databases where we have data normalized to a third normal form. Some more concepts relevant for dimension tables that you need to know: calendar dimension, which should be used in every single data model, hopefully, and slowly changing dimension, which is important from the perspective of DP-600. So with slowly changing dimension, that's a concept also introduced by Kimball and his team. Essentially, it refers to how you handle changes to the attributes that are happening to your data. Meaning, let's say I'm now located in Salzburg. I used to live in Belgrade, so I moved to Salzburg. So my location changed. How do I handle this change within the data? Let's say that I'm a customer in a system and those guys want to update data about myself. So how do they handle this data? There are multiple different ways and options to do this. There are different types of slowly changing dimensions, but usually most often and most commonly used slowly changing dimension type in analytical workloads is slowly changing dimension type 2. Essentially, let's go with 0, 1, and 2. Those are three that are most commonly used generally, not just in analytics, but generally. So slowly changing dimension type 0 means there are no changes to attributes. So whatever happens, I will always be, I will use myself as an example again. So I was born in Belgrade. I was in Belgrade. No matter where I move throughout my life, I will always be, my location will be set to Belgrade, which is not good, right? Because, yeah, you want to do some data analysis and perform how things changed over time. Let's say that you want to summarize amount per location. I'm not living in Belgrade anymore, so my my sales amount should be assigned to my current location, and so on. So slowly changing the measure type 0 is really something that we don't use in analytical workloads. Slowly changing the measure type 1 means you simply overwrite the existing value. Meaning, I used to be in Belgrade, then in 2016 I moved to Salzburg. From there, from 2016, so my location will be updated to Salzburg, and it will appear that as I'm always used to live in Salzburg. So I never used to live in Belgrade. There is no track of historical changes. That's slightly better, but it's not good again for analytical workloads, because if we do a comparison between locations in 2015 versus 2016, I want to see sales amount for myself in 2015 in Belgrade, in 2016 in Salzburg, right? This way, it will always be Salzburg until I move somewhere else, to Spain, for example, and then all of my sales amount will go to Spain. And then slowly changing the measure type 2. This is the one that we want to use, because it adds a new row for every change to the attribute. Meaning, I used to live in Belgrade until 2016. When I move to Salzburg, a new row will be added to a table which says from 2016 until in the future, so any future date, I live in Salzburg. Once I move to Spain, there will be a third row in this table which says Nicola from 2025 hopefully lives in Spain, and so on. So with slowly changing the measure type 2, we are essentially adding new row for each change of the attribute. Let's talk about some other important concepts in data modeling: normalization and denormalization. So normalization is not part of DP-600, but it doesn't make sense to talk about denormalization before we tell what normalization is, because as you may assume, denormalization is the opposite process of normalization. So normalization is process of organizing the data in a database, and in most cases, third norm, again, we have 6 different normal forms, and in most cases, third normal form is considered optimal. With normalization, the focus is on enabling the speed of data writing processes. So it's commonly used in operational databases where we need to improve the data writing speed. With denormalization, we are essentially creating redundant data in a table, and it's commonly used in analytical scenarios, in all-up scenarios, where the focus is on enabling the best possible speed of data reading operations. How denormalization looks in reality: let's say I have a fact table, fact sales, and I have 3 dimension tables: dim product subcategory, and dim product category. So in this case, let's say that I'm interested to see the total sales amount for category name. So I don't have this information in my dim product subcategory and dim product. So what's going to happen in this case, to retrieve the data for category name, I need to join first dim product table, I need to join dim product subcategory, and then I need to join dim product category. This is very often expensive when you need to read the data. What we do with denormalization, we store this data within dim product table, and essentially we create redundant data. You see that women value repeats in subcategory name and clothes value repeats in category name. So we create redundant data, but from the perspective of data reading operation, this should be faster. Not always, but in many cases it's faster. The next concept is aggregations. With aggregations, the idea is to basically take one big, large fact table and aggregate data on different attributes. In this oversimplified example, I have just 3 attributes. I have a date, I have customer ID, and I have product ID. In reality, you probably have more than that. But what's the idea? With aggregating the data, we are reducing the amount of rows that engine needs to scan. In this case, instead of having 5 rows, of course, in reality, it will be many more. So instead of 5 rows, I have one table which aggregates data per date, which contains 2 rows. And I have 2 tables, one aggregates data per product and the other per customer, that contain 3 rows. So essentially, we are reducing the number of rows, and all the queries that retrieve data per product or per date can read the data from these smaller tables. That's the idea of creating aggregations in general. Now let's see how aggregations can be created in Fabric specifically. Again, we have 3 different experiences: Lakehouse, Warehouse, and Event House. In Lakehouse, we do that using PySpark or Spark SQL. In Warehouse with T-SQL, and in Event House with KQL. The next operation is merging or joining the data. Again, we have those 3 previously mentioned, and again, language of choice is more or less predefined for all of them. But this time, for merging or joining data, we can also leverage a low-code, no-code experience with Dataflow Gen 2 for merging and joining the data. So if you don't want or you don't know how to write code in any of these languages here, you can use Dataflow Gen 2 and then leverage this rich graphical user interface to perform merge and join operations. When you perform merge or join operations, and this one is really important from DP-600 perspective, I'm pretty sure you will get a question that will ask you which type of join you need to perform to obtain result XYZ. So let's say we have two tables, very simple tables. One contains column fruit, and the other contains also column fruit. In first, we have apple, orange, and banana, and in the second, we have apple, orange, and mango. If we do a left outer join, then all the values from the first selected table, the one we think of it as on the left-hand side, but think of the first selected table in the query, all the records will be included, and the matching records from the table that we are joining. In this case, because banana and mango don't match, mango will be excluded from result set. Right outer join is, as you may assume, the opposite. So we take all the records from the second table and then matching values from another one. With inner join, only matching records between both tables will be included. So in this case, because banana and mango are not matching, they will be completely omitted from the result set. And finally, we have full outer join, which includes all records from both tables, where the mismatching is represented with null value or blank value. Yeah, you guys have a crystal ball in chat. I see, you know. Yeah, of course, it's not hard to predict the next topic, because I'm just following the official study exam guide. So yeah, don't pay some money to them for that. Okay, so identifying and resolving duplicate data in a lakehouse, we are using PySpark or Spark SQL, and there is this method drop duplicates. In this case, I'm literally telling from this data frame here, I'm checking customer name and email columns, and I want to remove all the duplicates from these 2 columns, and then return the column customer name and column email. So with drop duplicates, I can remove duplicates. In warehouse, this is one of the ways to do that. Obviously, there are multiple of them, but you can use a common table expression and then basically partition by IDs and assign row number. We will examine row number function in more details very soon, and then simply delete records that are where row number is greater than 1. And in KQL, you can use arg_max function to find the maximum value, and then from there summarize data based on this value. So with arg_max. Identifying and resolving missing data. Again, let's start with the lakehouse. And again, tool of choice is PySpark and Spark SQL. You want to find probably null values and replace them with something. In a lakehouse, there are 2 functions, fill NA and fill, which essentially returns same results. And you see some of the examples that I include, some code examples that I included here. So fill will simply take all missing values, in this case in city column, and it will replace it with, it will fill with unknown value. In T-SQL, we can use coalesce or isNull functions. Coalesce, they are slightly different. They behave slightly different. So coalesce will search for a first non-null expression. So you can provide multiple arguments to coalesce function. So it will literally first check class value of the class column, and if class is null, it will proceed and check color value for color column. If it's also null, it will go and check for product number value. As long as as soon as it finds the first non-null value, it will stop evaluation and it will return first non-null value. Whereas isNull checks the value in specific column and replaces it with a specified value. In this case, I'm checking if the value in max quantity column is null, and if yes, I'm replacing it with 0.00. In KQL, we have more nuanced choice. So isNull function, the same as in SQL, returns a Boolean result for non-string columns, so for numeric columns. isEmpty needs to be implemented if you want to check a result for string columns. So in T-SQL, isNull is implemented for all data types. In KQL, isEmpty is for strings, isNull is for numbers. This table illustrates the difference between these two. And then if you want to replace missing values, you can use series underscore fill underscore const, which replaces missing values in a series with a specified value, that you define. And also there is coalesce function that works exactly the same way as in T-SQL. Converting column data types can be done in multiple ways. Again, code first approach, lakehouse, warehouse, or event house, or low code, no code approach using data flows Gen 2, and then also with pipelines in copy data activity. As you saw, I can change the column data type during the process of setting up copy data activity. So in a lakehouse, we use cast operator to change the data type. In a warehouse, remember, alter table is not supported, so you can't use alter table, but there is a workaround. So what you can do, you can use a system function sp underscore rename to rename the table, and then change the type, and then create table as select with new data types. It's a workaround, so you definitely don't need to know this for DP-600, but for the real life, this can be useful workaround. But alter table is not supported. And in event house, there are two options: alter column and set or append. With alter column, it's as simple as that, as simple as it should be in a warehouse, but it doesn't exist. So with alter column, you just specify a table and column name, and simply type that you want to change the column to. And set or append, which creates a new table and preserves existing data while changing the column data type. Yes, Fernando, there will be break very soon. Just a few more things to cover. Converting column data types. So here we have to no code approach in data flows Gen 2. In pipelines, copy data. As you saw in this example that they previously did, we can change the type of the column in destination. And in data flows Gen 2, obviously you can convert column data type the same as you do in Power Query. Filtering data, again, depending where your data is stored and when you perform filter operations. If you do it on a lakehouse, then there are two functions to be aware of: select, which returns subset of columns, and filter, which returns subset of rows. Then in a warehouse, select and where. And in event house, project is equivalent to select, and where is same as in SQL, subset of rows. Filtering data is also possible within the pipeline and within the data flow. In data flow, again, same as in Power Query, you simply open this down arrow and then you choose the values that you want. And in pipeline, there is a filter activity that allows you to specify which rows should be loaded into Microsoft Fabric. Okay, so we are done with transform data. Let's do a short break of, let's say, 7 minutes, and then we restart with the query and analyzing data and proceed from there. Okay, welcome back from the last break. There are no more breaks. Sorry about that. But yeah, we are slowly leaning towards final parts of the session. And please stay here because we are going to play quiz. And I promise this will be super fun. First of all, thanks Fernando for donation. Really appreciate that. Thank you, thank you. And please excuse if I missed someone's donation to mention you, but I really appreciate that. Thank you so much. Okay, so let's jump into final part for our prepare data topic, which is query and analyze data. So the first and the most straightforward way, especially for people who are not coders, is to use Visual Query Editor. That's a new feature that was introduced with Microsoft Fabric. And here, for example, if you expand this new SQL query drop-down menu, you will see the option New Visual Query. And this new Visual Query, this is how it looks in Fabric Workspace. So as you see, it reminds of a data flow Gen 2. And essentially, it allows you to drag and drop tables and perform different transformations to the data by using well-known experience from data flows Gen 2. So you can think of Visual Query Editor as a data flows on top of SQL tables that you used. And you see merge queries with left join and so on, choosing columns, so doing some data cleaning and so on. So this is Visual Query Editor. The next option is querying data with SQL. Obviously, this session will not teach you SQL. For that, you either need to read a book or attend like a multi-day course. But yeah, so let's focus on elements of SQL, T-SQL language that is important from the perspective of DP-600 exam. So we will examine specific group of functions in T-SQL, those analytical functions that you can expect to be tested on during DP-600. So first group is window functions. Window functions contains of few building blocks. The first one is over clause, which defines a window. Then we have a partition by clause, which is optional, and it breaks the rows into smaller subsets. So think of it as creating small subtables, virtual subtables within the main big table. And finally, we have order by. Depending on which function, which window function you are using, it may be required or not. This is a very simple example of window function row number. Let me zoom it a little bit. So each window function starts with over keyword. And then in this case, I'm creating partition for each customer key. So each customer key value in my big table will be considered as a small subset of records. And everything that I perform from there will be applied on this small subset of records. In this case, I'm also using order by clause to sort the records in this subset based on the order date. The next group is ranking functions. Ranking functions, there are 4 of them: row number, rank, and dense rank. And the fourth one is entile, which I didn't include here. So just to explain the difference between results, when you see results, you will see that you will understand the difference between behavior of all of these 3 functions. So with row number, essentially what I'm doing here, just first let's explain this. So essentially, I created a partition on each customer. In this case, I have a customer with ID 11330, and with row number, and I also partitioned by order date. So you see that in this case, I have 2 orders which were made on 24th of October 2013. And with row number, it just simply increases the value by 1. So it doesn't take into account any differences here or any identical values. So in this case, these two values are completely the same. So it assigns row number in completely arbitrary way. With rank and dense rank is different. So with rank, I have these 2 records on 24th of October. And then the next one is on 4th of November. So what happens in this case? With row number, again, it's fairly simple. With rank, because these two are exactly the same from the perspective of the order date, right? So we are not doing any other check. We just check the order date. So from the perspective of order date, these two are treated equally. So this is number 6, and the next one is also number 6. But what I want you to focus here on is the next value. So the next value starts with 8. There is a gap here in between because we have two records with the same value. Then there is a gap of 1, and the array continues with number 8. If I had 3 values with the same here, 24th of October 2003, then it would be 669, because there will be 3 records with the same value. That's rank. And then if we move to dense rank, if we move to dense rank, it's the same as rank. The only difference is here. With dense rank, values continue from the next number. So it doesn't matter if you have 2, 3, 5, or 100 records with the same dense rank value here. The next will start without the gap. So there is no gap with dense rank. Please remember this difference. This is 100% tested on DP-600, the difference and the expected result set. Query data with SQL finally offset functions. There are 4 of them: lag, lead, and first value, last value. Again, we are creating a subset of values. In this case, I am partitioning data per customer. So this is my partition number 1, customer ID 11,000. This is partition number 2, partition number 3, and so on. So lag function simply retrieves the value from the previous row. You see, it's simple as that. Whereas lead does exactly the opposite. The lead takes the next value, the value from the next record, and puts it here. That's next order. And then first order and first value and last value will simply take the first value of the partition and assign it to all the records within this partition, within this subset of records. Last value will do the opposite. So we'll take this value and place it on all 3 records here. So these are first value and last value. With KQL, we are using an item which is called KQL query set, which represents a collection of 1 or more KQL queries. And the main benefit of using KQL query set item is that you are able to easily share queries with others. Be aware that using explain keyword, if you are a SQL person and you don't know KQL, you write your SQL, you prefix it with explain keyword, and it will translate your SQL to KQL statement. So the statement that I wrote here, this is T-SQL, and this is the equivalent written in KQL. So with explain, you get KQL translation. Pretty cool. You can write T-SQL without this explain thingy. So you can write T-SQL to query the data from KQL. But that's why I put this but. You shouldn't do that. KQL is not built to use T-SQL to query the data. There are many functions in KQL that are optimized for working with streaming data that we stored in KQL databases. So generally, you want to use KQL. T-SQL should be avoided. Although it can be used, it should be avoided. And as a backup plan, you can always use this explain and to translate this to KQL. I want to show you a few examples of, let me see if I have some queries. No, I don't have here. Maybe if I go here and then warehouses, just to show you a few examples of queries. This is a visual query I created, I think. Yes, so this is an example of visual queries. And let me find, I'm not sure where I stored I have views, I have store procedures. Then let's go and show, it's better to show then KQL queries. T-SQL is T-SQL. I already showed in these slides a few examples of T-SQL functions that you need to learn and understand for DP-600. I want to show you here what I have in my KQL database. So this is my fundamentals MS Fabric RTI. This is an event house, and in this event house, I have one KQL database as of today. And here, this one is a query set. That's the item that I mentioned previously. So this one allows you to store a number of different queries, and then you can share this item with the others within the organization. So this one will simply count records in a table. Then this one, for example, will filter the data. So just give me the data where the state equals New York and event type is winter weather, and include only those columns. Remember, when you want to filter the data, project is used to filter out the columns that you want. In this case, I'm just returning 5 columns. Here we are creating a calculated column. Remember, it's simply calculating here in project, and I'm returning just top 10 records. Using summarize operator to show me number of records grouped by each state. So for each state, I'm counting the number of records. I can also visualize results. In this case, I'm using bar chart. This one is conditional count. This one uses max function to aggregate data and calculate the maximum number of injuries per each state. And also, I'm renaming the column. So in this case, I'm using alias injuries direct, and I'm returning just 2 columns with project keyword. These are some very basic examples of KQL queries. Okay, cool. Let's move to the final topic, and it's implement and manage semantic models. For all of you Power BI people, this one will probably be the favorite. So let's jump in and see what's in there. Two main. This part was not changed almost at all as of 15th of November. So let's start with designing and building semantic models. You see the subtopics that are measured, skills that are measured within this design and build semantic models. So let's first examine the feature which is called direct lake. But before we examine it, let's take one step back and understand the Power BI architecture from the perspective of someone who doesn't use Fabric or didn't use Fabric. So what we had before Fabric, we have not what we had before Fabric, but what we have still, but it was relevant also before Fabric. So it's not that those two are not relevant anymore. Apologize for that. So we have first and default choice when building our Power BI semantic models is import mode. And as Microsoft suggests, and as we witnessed many times in real life, import mode should be a default option. And I like to quote Chris Webb, who says you should always use import mode unless you have a good reason not to. So import mode should be a default choice when designing Power BI models, especially before this direct lake became a thing. So with import mode, what we have some data sources here on the left hand side. I have those tables. You can think of them as SQL tables, Excel files, SharePoint lists, whatever. And then we take this data and we import this data here into Power BI's model. So this cube here in the middle, this is Power BI's model. Okay, that is a database called Vertipack where Power BI stores the data. And then we have Power BI reports all the way on the right. And when your user interacts with the report, those visuals generate some DAX queries in the background. and those DAX queries are then executed against this VertiPack database, against this local copy of the data that is stored in Power BI. So these queries don't touch the original data source. And from a perspective of import mode, the best thing is blazing fast performance. And we talk about a columnar in-memory database, VertiPack, which stores the data in a highly compressed format. So these queries are usually super fast, and data is stored in memory. But we have two, let's say, downsides when using import mode. First is data duplication, because essentially the data we have here on the left-hand side is literally copied physically into Power BI's database. So we have two versions of the same data. We have the same data at two different places. And the other problem, let's say, is data latency. Why? Because when you import the data into Power BI, you are taking a snapshot of the data from the data source at certain point in time. So now it's 8:15 in Salzburg. Let's say that I imported my data at 8:15 into Power BI's database here. As long as I don't bring new data, fresh data from the data source here, my DAX queries will retrieve only this data that is stored in Power BI's database. Meaning, if I brought 10,000 records at 8:15, and then in next 15 minutes I have 1,000 new records coming into my data source, these new 1,000 records will not be reflected in my Power BI's model until I refresh it. And then I pull another snapshot and bring what is currently stored then at that moment in a data source. So this is import mode. To resolve some problems of import mode, we have direct query as the opposite of import mode. With direct query, no data is stored in Power BI's database. So in this case, this cube in the middle, this VertiPack database, stores metadata only. So information about the tables, columns, data types, and so on. But physical data is not stored here. And that means when your user clicks on the visual in the report and generates DAX query, this DAX query will be translated to a SQL, and query will be executed against the data source directly. Which brings us to important conclusion. This time, there is no data latency, because whenever user interacts with the report, the visual will generate the query, and that query will retrieve what is the latest data at that moment in the data source. Okay, so there is no data latency. There is no data duplication, because data stays here. It's not retrieved, it's not stored in Power BI's database. It's just taken during the query execution and populates the visual, but it's not stored here. So there is no duplication. And then the question is, yeah, why? Because direct query is so cool. There is no data duplication. There is no data latency. Why don't we use direct query always? Because of this. And I'm sure all of us, whoever use direct query, can confirm that, yeah, if you don't talk about few hundreds or few thousands of rows, as soon as your data scales, you will run into issues with performance. And this is really something very often which is not acceptable for end users. So that's why we are still using import as our default choice. And now with Fabric, we have a new option, which is called Direct Lake. So Direct Lake tries to leverage all the best things about direct query and import mode. And so the idea is to bring the performance of import mode, or very close to import mode, and avoid data duplication and data latency the same as in direct query. So what happens with Direct Lake? It's, from conceptual point of view, it's same as direct query. So user interacts with the report generates DAX query. DAX query is executed directly against data stored in one lake. Remember, we store data in Delta files, in Delta tables in one lake. So these queries will be executed directly against those files. But because Delta, or let's say Parquet, which is the native format in the background under the hood of Delta. Parquet stores data in a way which is very similar to this, very, very similar. So it's columnar structure. And because of that, Power BI's engine is capable of quickly transcoding this data and putting it here in its in-memory optimized storage. So we are basically getting the performance similar to import mode, sometimes the same as in import mode, depends on different things, but let's say similar to import mode. With the concept of no data duplication, data still stays here physically. Power BI just loads certain columns that are needed by query. It loads them on demand here in its Vertipack database. So that's Direct Lake in a nutshell. What are the prerequisites for Direct Lake? First, Fabric capacity or Power BI Premium. So if you are using Premium per user, you are out of luck. So Fabric, either F or P license. Lakehouse with a SQL endpoint for direct query fallback. We're going to examine this in a few minutes. Or Warehouse. So Direct Lake works on both Lakehouse and Warehouse. Delta tables. So if you store data in other format than Delta, no Direct Lake. It's not possible. And then we have this view ordering where I intentionally put this asterisk at the end because it's not a hard prerequisite, but essentially it will ensure the best possible read performance when your Delta tables are view ordered. Without going too deep into explaining what view ordering is, think of it as a Fabric specific way of additionally optimizing data in Parquet files during the data writing process. So all the engines, when they write data into one lake, they will by default apply this view ordering. It's kind of reshuffling the data, sorting in a specific order. So once the engine needs to read the data, it's already sorted. It's quicker to retrieve the data. That's the logic behind view ordering. Some limitations as of today, again. Querying one single lakehouse or warehouse, meaning if you want to combine data from multiple lakehouses, it's not possible. But you can use this concept of shortcuts, remember? So I have a lakehouse A and I have a lakehouse B. Let's say in my semantic model, Direct Lake semantic model, I need tables from both lakehouse A and B. I can't do that out of the box, but I can create a shortcut in my lakehouse A, which points to a table in lakehouse B. And from there, this table will be accessible from lakehouse A, and then Direct Lake model can read the data from there. T-SQL views are not supported. We already mentioned that, so you can include them. So you will not get an error or something like that. You can include them in Direct Lake model, but all the queries that get the data from those views will fall back to direct query. DAX queries that are exceeding limits based on the size of your Fabric capacity, or if they're using any unsupported features, will fall back automatically to direct query. No DAX calculated columns. I don't know if this is good or bad, but if you rely on implementing your calculation logic with DAX and DAX calculated columns in DAX, then again you are out of luck. It's not supported in Direct Lake. No composite models, at least not yet. So it's just Direct Lake, all or nothing. You can't use 3 tables in Direct Lake, 2 tables in import, and so on. And no relationships on date time columns. So just to be clear, you can have tables in your model that are date time data type, but you can't create relationships on those columns. And again, I've included a link which lists all the current limitations, and make sure always to double check what's currently up to date, because yeah, this list used to be way longer previously when I did explanations for Direct Lake. Now some of these limitations are lifted. So yeah, let's talk about relationships and how to implement them. First of all, unlike in traditional relational databases, they have in semantic models, in Power BI semantic models, they have additional role or additional purpose to serve as filters. When we are executing DEX calculations, filters are being propagated through relationships. So let's first examine the concept of cardinality in relationships. And there are 4 possible options: one-to-many, many-to-one, one-to-one, and many-to-many. So let's start with one-to-many, many-to-one. The one side means that the column contains unique values, whereas the many side means that the column may contain duplicate values. One-to-many and many-to-one are essentially the same from cardinality point of view. The only difference is where the relationship starts from. And I'll give you a very simple example. Let's say that we have 2 tables in our model, product and sales. And there is a product key column in both tables, and we create a relationship between 2 tables on that column. However, since the product key in the product table contains unique value, if we define a relationship from this column to the product key column in the sales table, this will be one-to-many relationship. If we do the opposite, it's going to be a many-to-one relationship, since there can be many product key repeating values in our sales table. One-to-many should be your preferred choice when you're designing Power BI semantic models. No discussion about that. So we can talk about that in more detail in some other sessions, but one-to-many for multiple different reasons should be preferred choice whenever possible in Power BI semantic models. One-to-one relationships are usually a sign of suboptimal model design and should be reconsidered whenever possible. So try to avoid one-to-one. It's usually a sign that you didn't do a proper data modeling. Many-to-many relationships are also considered as exceptions rather than a rule. And there are certain scenarios where using the many-to-many relationship would make sense, such as connecting fact tables with different grain or connecting many-to-many dimensions. And a good example of this should be, let's say we have a model that contains 2 tables, customer and account, and one customer can have multiple accounts. Also, one account can be shared by multiple customers. In this scenario, a recommended practice in Power BI semantic modeling is to create a so-called bridge table, which stores unique combination of each customer and account. And then we create 2 one-to-many relationships between our dimension tables and the bridge table. Okay, another important concept when designing relationships is filter direction. There are 2 possible options to choose from: single direction, which is a recommended practice, and filter in both direction or bidirectional filter. This option has its use cases, but should be implemented with special care. The arrow on the relationship reveals the filter direction. In this case, we are talking about the single filter direction going from the product category table, then to the product table, and then all the way to the sales table. This means we can filter values in both product and sales tables by selecting a value in the product category table, but not the other way around, okay? But if I set filter direction to both, then we would be able to propagate filter values in both directions. Again, bidirectional relationships should be used with special care because they can cause inaccurate results and performance issues. In case there is a need for specific calculation to leverage bidirectional filtering, the recommended practice is to implement it by using cross-filter DEX function for that specific calculation only. And then with cross-filter function, you can open the relationship in both directions just for a single calculation instead of keeping it open for all use cases. Okay, so next concept is DEX variables, and this one is sometimes overlooked by new users in Power BI. DEX variables have 3 main advantages. First one is to reuse expression logic. The second one is to improve performance because they will be evaluated by engine only once instead of multiple times, and they also help to easier debug your DEX code. So this is an example of using variables versus not using variables. And in this very basic example, you see that how easier is to understand and read the first statement here on the top versus the second one, where I basically repeating the same thing multiple times. So use variables whenever you can. Iterator functions are called iterator because they are iterating over a table, and they evaluate the expression for each row and then finally aggregate result. So how do you recognize them? They all end with X. So relatives of scalar functions like average, count, sum, mean, and max. So average X, count X, sum X, and so on. Those are iterator functions. They are iterating over each row, calculating the expression, and then finally aggregate the result. Aggregation depends on what you want to achieve, average value or sum or whatever. Keep in mind that when you write a DAX expression like this, total sales equals sum of column within a table, this will be internally translated to this version down below, to sum X. Okay, so even though you don't explicitly write it, the engine will translate this expression like this. And what is most important thing, please keep this in mind, also for DP-600, but also for your work, whenever you need to calculate the expression that includes more than one column, you must use iterator function. So you can't use scalar functions if your expression includes multiple columns. Let's now talk about window and info functions. So window functions, we already examined some of them in SQL world, but yeah, they're relatively new enhancement in DAX language. So similar to SQL, they aim to provide possibility to calculate specific expressions over a sorted and partition set of rows. So things like sorting customers by total amount spent, or comparing the sales from current year and previous year, or calculating moving averages or running totals. For those use cases, window functions are perfect fit. They also rely, similar to the SQL relatives, to arguments partition by and order by. Partition by determines the window itself, same as in SQL example. So subset of rows where we want to apply our calculation on, whereas order by defines the sorting order of the results within that window. Let's first introduce an index function, the index function, because that's the most straightforward one. This function simply returns a particular row of the table based on its position. For example, if you want to return the brand with the highest sales, you can use the index function and specify number 1 for the best performing brand. In case you want to return the second, you just simply switch this number here to number 2, and so on and so on. In this example, I haven't used partition by clause, which means that we perform our calculation on the entire table. Now let's imagine that we need to identify the highest selling brand within each category. So not the overall highest selling brand, that we already calculated that, but top performing in each category, such as audio, computers, accessories, and so on. So partition by will create smaller subset of rows, and then we perform our calculation in the scope of each of these smaller subsets of rows. This is index. Then we have offset. Offset is similar to lag and lead function in SQL. So this one with -1 will return the value from the previous row. If you do -2, then it will go 2 rows back, and so on. If you include positive values here instead of negative, then it will move forward and introduce next values from this one. Okay, window function is probably the most complex one. We have a basic table which shows the total sales amount for each year. So let's say, not for each year, for each customer, sorry. I'm analyzing 2 customers here from the AdventureWorks dataset, Adam Young and Alexander Jenkins. And here is the summary of their orders and total sales amount. And the first concept to understand here is that we want to treat each customer as a separate entity, meaning we want to create a window for each customer, and then analyze figures for that specific set of rows. In our case, we will have two windows here. My first window is customer Adam Young. My second window is customer Alexander Jenkins. Now, window functions in DAX can work in two different ways, either by operating on a relative value based on the current row, or by operating on an absolute value. In my case, I always want my window to start at the first row of each partition, so each customer is a partition, and finish on the last row of the partition. So this measure will allow me to calculate a running total of order quantity and sales for every partition. Now this looks super complicated, but it's not, trust me. Essentially what you need to take into account is how do you create your partitions and how do you set your arguments for taking relative versus absolute value and how many rows you want to go back and forth within this. So those are three key things to keep in mind with window function. Information functions are functions that can be used in multiple scenarios. The most common is when you need to obtain information about the data type or filter context. For example, of course, there are many information functions, but some most commonly used are contain string will return true if one text string contains another text string or has one value which evaluates to true if there is only one value in the specified column. We also have another group of information functions recently introduced that starts with the keyword info and then dot after that. Then you can obtain a bunch of useful information about your semantic model and its core elements such as tables, columns, measures, calculation groups, data sources, and many, many more. Okay, some more features that are relevant for DP-600. Calculation groups. So calculation groups, instead of giving you a dry definition, I'll try to share a descriptive version. And imagine that you have a fact table which contains 10 different metrics, 10 different explicit measures, such as sales amount, sales quantity, discount amount, return quantity, and so on and so on. So you go and create 10 measures for each of these metrics. So next step is to provide your business users with additional information. For example, what was my sales amount in the previous quarter, or how has my sales amount sales quantity developed year over year, or what is the running total of the return quantity in the selected period, and so on and so on. So how do you achieve this? Of course, you'll write a measure to calculate the sales amount for the previous month, measure to calculate the sales amount for the previous quarter, measure to calculate the sales amount for the previous year. Then you will write the same set of calculations for sales quantity, then for return quantity, and so on and so on. And you quickly end up with 50 or 100 measures in your semantic model. And what's the deal? Most of them contain basically redundant logic. You're just copy pasting the expression and you just switch the base measure, which is sales amount or sales quantity, whatever it is. So here is where calculation groups come to the rescue. With the calculation group, you set a placeholder for the specific base measure. For example, base measure is our sales amount. And then you define a set of calculation items that will be applied to that placeholder measure. I know it sounds a little bit confusing, so let me show you a simple example of the placeholder measure. So placeholder measure is defined by using selected measure function. And this function will evaluate the measure that is currently in the context. Whatever measure is currently in the context will be evaluated through this selected measure. And then we have one or multiple calculation items for this measure in the context. In this case, I have two calculation items, one for month-to-date calculation, which is on your right, and year-to-date on your left. And as you see, the only difference is the calculate filter modifier. There are no two separate measures anymore. It's just a single base measure in the scope. We are talking about sales amount here, and then these calculation items will be simply applied on this measure in the scope. Okay, The next thing is field parameters, one of my favorite features in Power BI. So let's examine how to leverage this to push your Power BI solutions to a whole new level. In a nutshell, field parameters allow you to perform two actions: dynamically change the attribute for slicing and dicing the data in the visual, meaning dynamically switch between different columns, and dynamically change the metrics displayed in the visual, meaning dynamically switch between different measures. And I hear you, Nicola, we could have done this before field parameters as well. Yes, that's true. But instead of DAX complexity, using tree tests and all this exotic stuff, you can now set everything up with just a few clicks and without writing a single line of DAX code. So maybe I can show you quickly a demo of field parameters. Let me first, okay, yeah, never mind. So how do you create field parameters? Again, you need to first to enable them in preview features. More than 2 years, they're still in preview feature, but they work well. I can confess that I implemented them in real life multiple times. So under modeling tab, and then new parameter, choose fields. But let's first build a visual so I can show you later how to put field parameters in. And let's say that I don't need this. Let's say I'm showing total sales amount, which I don't have, but I will create now. So I have sales amount equals sum of sales amount. And let's create a new one for quantity. Order quantity equals sum of order quantity. And let's say I'm showing here total sales amount by product color. Now, wouldn't it be cool if I can somehow now, instead of color, if I can display my data here based on, for example, I don't know, education of my customer. Okay, so instead of color, I want this view, the same calculation based on the customer education. So previously, as I said, this was very hardly achievable with some decks or using bookmarks, overlaying visuals, and so on. So let me show you how easy it is to do now with field parameters. Again, going to modeling, new parameter, and then fields. So let's call this one, I don't know, attribute switch. And then I'll choose my product color, and then I'll choose my English education. And I can choose to add a slicer to a page or not. In this case, I want slicer to enable me to do this. And what happens when you create field parameter? There is a new calculated table in your model, which is called attribute switch. And here is a definition. So you can change this and say, instead of English education, I just want to call this education. So now when I click on this slicer here, obviously nothing happens. But let's put our column from our field parameter table here on x-axis. And now what happens if I click on color? It's color. It's now education, and so on and so on. That's one thing. So I already told you can switch dynamically attributes between different columns. But here, wouldn't it be cool if we can switch between sales amount and order quantity? Again, you can do that with field parameters. So I'll create a new one. Let's call this one KPI switch. And let's put our order quantity and sales amount. And again, leave this in a slicer. So now instead of sales amount on y-axis, I basically want to use this KPI switch value. So currently is order quantity, now it's sales amount. Now it's color of sales amount, color order quantity. So full flexibility, I built this in 3 minutes. No DAX, no bookmarks, just field parameters. I love them. Okay, so going back to a presentation, dynamic format strings, another feature that can help you enhance the look and feel of your Power BI solutions. So it helps you to determine how measures appear in the visual. It's usually a cumbersome and tedious task it was previously to dynamically format, I don't know, currencies or whatever. Now you can conditionally apply a format string with a separate DEX expression, and essentially it allows you to overcome the limitations of the format function. So this is the example of implementing dynamic format strings. So under format for the specific measure, you choose dynamic, and then here under formatting, you define the format you want to use. Just to show you how it looks in Power BI, let me go to my order quantity. So here under format, I select dynamic, and then here I can define, for example, I don't want 0, like this, for example, and so on. So you can define how you want to format your measures with dynamic format string. Large semantic models, working large semantic models in Power BI, we will go over 4 hours for sure. So yeah, hope you will stay with us. Large semantic models in Power BI. First, before I show you how to enable or disable this option for your semantic model in a workspace, I want you just to reiterate about different types of tables that we are using in our semantic models. So we have two main types of tables in our models. We have a tall table with many rows and not so many columns. We are usually building our fact tables to be narrow and long. Okay, so that's a tall table with many rows and not so many columns. And then we have usually dimension tables which don't contain millions and millions of records. There are exceptions, but usually your dimension tables are smaller in terms of number of rows, but they can be very wide. So there can be dimension tables with, I don't know, 50 plus columns. So those are considered wide tables with many columns and less rows. And Power BI is built in this way to efficiently handle both of these scenarios. But if you build your table like this, to be both tall and wide, to contain many rows and many columns. In other words, if you use one big flat table, this is usually not a good idea for Power BI, at least. There are some tools out there, I'm sure, that work well with one big flat table. Power BI is not one of them. So you don't want both tall and wide tables in your models. And then when you build these models, there is a feature called, or option called, enable large semantic model storage format. This one allows your model to go beyond the default limit. Default limit is 10 gigabytes. Above that, you can't, essentially, if you don't enable this feature, your model cannot be larger than 10 gigabytes. But if you enable this feature, then your model can grow up to the size, to the maximum size for your defined by your capacity. So if we talk about, for example, F64, which is equivalent to P1, the maximum model size is 25 gigabytes. This doesn't mean that you can have 5 models of 5 gigabytes. So each individual model can be up to 25 gigabytes with this large semantic model storage format enable. So limit is per model, not the sum of all models. Also, what Microsoft suggests, I didn't test it myself, so I cannot confirm if that is true or not, that this enabling this feature will also help smaller models. So if you also have models of a few hundreds of megabytes, because it will improve XMLA write operation performance. In semantic model settings, there is a property called large semantic model storage format where you can turn it on, or in the workspace settings, this one on the left hand side will turn it on just for a particular semantic model. Whereas if you do that on a workspace level, then all the models will be converted to use this large semantic model format. The idea is to, with this one, Power BI handles automatically semantic model eviction from the memory. So if the model is not used and there are no operations on this model, Power BI will automatically kick it out from the memory, and also on-demand load, meaning only those columns that are needed by DAX query will be loaded into memory. That's how this property works. Talking about composite models feature in Power BI, we are talking about composite models, there are two possible use cases. When you combine two or more different direct query sources, or when you combine one or more direct query sources and import mode. Please be aware that all imported data is considered as one source. So never mind if you connect from Power BI to Excel file, SharePoint list, SQL database, and you bring all this data into Power BI import mode. From composite model perspective, that's one source. So it's not three sources, it's one source. And then every direct query is a separate source group within this composite model. You can see in this illustration, I have different types of arrows. Some of them are regular arrows, some of them are dashed. And if you're wondering what these dashed lines represent, they represent limited, so-called limited relationships. Limited relationships exist between between the tables that are in different storage modes. And in this case, I have one data source, which is Oracle database, one data source, which is direct query over SQL Server database, and my imported data is considered as a Vertipack data source. So whenever you establish relationships between tables that are in different source groups, they are considered limited relationships. Aggregations in Power BI, we already talked about aggregations previously in general when we talked about lakehouse and warehouse. In Power BI, aggregations go one step beyond because it allows you to define aggregations on a semantic model level, and that your queries will be automatically remapped and executed and results retrieved from those aggregated tables. The key thing here is to make Power BI aware of aggregated tables. So once you create your aggregated tables and put them in the model, that's not enough for Power BI to know about them. So you need to make Power BI aware of these aggregated tables, and this is achieved by using Manage Aggregations option. Once you click on a table, there is an option Manage Aggregations, and there you define how you want your aggregations to behave. Please keep in mind this slide. This slide is important because you will for sure get a question on DP-600 about the best storage mode choice for specific table type in your composite model. When you are creating aggregations in Power BI, the original table must be in direct query storage mode. So it's not possible to create aggregations in Power BI if the original table is not in direct query. It must be direct query. Then dimension tables, they can be both import and direct query, but from performance point of view and to avoid this limitation that we mentioned previously of limited relationships, dimension tables should be set to dual storage mode. Dual storage mode is the one with dashed line on the top, this one here. So dimension tables should use dual storage mode, and then depending if the query is retrieved from the aggregated table, they will behave as import mode. If the query is retrieved from direct query table, they will behave as direct query tables, and you will have regular relationships between those tables. And aggregate tables, those where we aggregate data, should be in import mode. Again, technically you can put them in direct query, but should be in import mode because the overall idea is to improve the performance, and we already learned that performance is significantly better with import mode compared to direct query. We are done with designing and building semantic models, and one last thing, optimizing enterprise scale semantic models. Let's talk about first who complains about performance, so we know where to look for a problem. If it's your DBA or someone from your IT department, probably your issues are somewhere in the background, and we are talking about data model size or data refresh process. If your end users, your final report consumers, are complaining about the performance, usually the problem is somewhere on the front end, and it's most commonly it's either DAX measures or visuals rendering time. Luckily, Power BI provides a built-in tool which is called Performance Analyzer in Power BI Desktop that helps you to capture key metrics of the report performance. Now, what does this performance analyzer is capturing? Three things or three items. DAX query. DAX query refers to time needed to return query results. Visual display, which represents time elapsed for visual rendering. And the final one, which is the trickiest one, and it's called other. Other can mean many things, but usually in 99% of cases when the value for other is high, this means that the specific visual had to wait in the queue for all the other processes and queries to complete. Because don't forget, Formula Engine in Power BI works in a single-threaded way. So if you have 20 different visuals on your report page, each of them they will be executed in sequence, so not in parallel. And that means that the poor 20th guy has to wait for previous 19 to complete before it gets its turn. So how it looks like from Power BI perspective, you can turn on Performance Analyzer from Optimize tab or from View tab, it depends, Performance Analyzer, and then you click Start Recording. And once I refresh visuals, you see that, okay, in this case, it's super fast because it's simple and I don't have too many visuals. So what is here? Because we have field parameters, it's also evaluated parameters. But those are three metrics that I mentioned: DAX query, visual display, and other. So this other means that this visual here had to wait 25 milliseconds for all the other processes on the page to complete before this one could be executed. So you can sort results here per different items, let's say per total time, and then I can sort in descending order. And this means, for example, this one had to wait 69 milliseconds and so on and so on. So Performance Analyzer is a great tool to give you a first hint about what is the problem with the report page. And then from there, you can explore and try to troubleshoot performance by using many different techniques, obviously. Eugene has course on Power BI performance tuning. It's great, so I encourage you to check it, and you will learn how to optimize most of these scenarios. If you have many visuals on the report page will render obviously slower. If you reduce the number of visuals on a report page, it will perform better, obviously. Some of the bottlenecks, most common bottlenecks, if we talk about the visuals, reduce the number of visuals. Not sometimes, but more often than not, keep it simple. Simple is better. So don't try to over impress with too many visuals. Reducing the number of visuals will speed up the report and remove the clutter from the report page. So it's a win-win situation. For DAX queries, I don't have good news. You need to learn and understand DAX, so we cannot talk about that. But you know what are the best sources. Go to sqlbi.com or check the book Definitive Guide to DAX, and learn and understand how DAX works, and then you will be able to optimize your DAX queries. A few more words about data refresh process in Direct Lake. Internally, this process is called framing. Essentially, with Direct Lake, there is no classic refresh like with import mode models. With the import mode models, Power BI will literally pull the data, physical data from your data source, and bring this data into its local database called Vertipack. With Direct Lake, it's not pulling any physical data, it's just a metadata refresh process. So that means that even for large tables with hundreds of millions or even billions of rows, this process of refreshing data should be very fast, maybe like 20-30 seconds max. This is the illustration of how this process works. So what I have here, I have a lakehouse, and I have a delta table, and I have different versions of the file for this delta table. Let's say there were 4 versions of files for this table so far, and this is my Direct Lake semantic model. So currently, what Power BI will do, will create a frame and take the last version of, take these files that are currently relevant for semantic model. And then let's say a new file pops up. Okay, so this one is not included in my semantic model. So what happens? Power BI will first kick out everything from memory and then extend the frame to include the metadata information about this latest file that came. So this is the process of refreshing data in Direct Lake. No real data from these files. So no real data goes there. No. It's just a metadata. Like I have this version and I have some information here about data types and so on and so on. This option is by default turned on, meaning Power BI will check every minute or so if there are new records in the underlying table, and it will synchronize the data with Direct Lake semantic model. But maybe you want to turn this off for different reasons and do this automatically, or do this with more control. For example, maybe once your ETL process is done, you want to refresh your semantic model, for example, using pipelines like we did at the beginning of this session with this semantic model refresh activity. And one last thing that I want to show you is Direct Lake behavior property. There are three options here to choose from. We were talking about falling back to direct query. Remember, I mentioned multiple times, if for whatever reason Direct Lake cannot be achieved, Direct Lake behavior, by default, this query will fall back to direct query mode and will be executed as regular direct query query against SQL Analytics endpoint. So this is a default behavior. If you set this property value to automatic, that means direct query if Direct Lake cannot be used. Then you can change this to be Direct Lake only, meaning if for whatever reason there is no Direct Lake, then you will get an error. And finally, direct query only, as its name says, no Direct Lake happening at all. How do you set this? I need to open, let me go to my workspace and find some Direct Lake model. Let's close this one. And for example, I think I have something here. I'll click on three dots and then open data model. And then here under model, it's Direct Lake. So I forgot where to find it. Tables, relationships, tables. It should be somewhere here. Here it is. I need to click on semantic model here at the top. And then Direct Lake behavior, as you see, it's automatic. It can be Direct Lake only, meaning no direct query, or direct query only means the opposite. There is no Direct Lake. So you can set this, you can change this behavior here. Okay, and then let's go back to a presentation. Incremental refresh, I think that's the last topic. Way to optimize workloads in Power BI workloads. So the idea of incremental refresh in general, so we are not talking now specifically about Power BI, is that we want to synchronize data. We have data coming in, storing from applications and all the other stuff in our transactional database. And we want to synchronize the data between transactional database and our central storage location. Let's say it's our data warehouse. So we're talking about things before Fabric. And if we each and every time load the data from the entire table, this is time and resource consuming. So we want to avoid this scenario. And the idea about incremental refresh is check when the data was last time loaded into our central storage repository. If that was, for example, yesterday at midnight, I don't want to check, I don't want to change the records that were previously already loaded. I just want to load only those records that came after yesterday midnight. In Power BI, incremental refresh works in a little bit specific way. All Power BI tables consist of single partitions. So it doesn't matter if your table has 2 rows or 2 billion rows. It's by default a single partition, always. And then with incremental refresh, the idea is to split this partition or split this table into 2 partitions. One partition which contains rows that don't change, and another one which contains rows that are changing, so they're more recent records. This is an incremental refresh workflow that happens in Power BI. You see that what was previously a real-time data now after 1 day becomes incremental refresh data, and this is so-called rolling window pattern that is implemented during the incremental refresh process, and this process just goes every single day. It moves the window one step back. Some of the prerequisites: you need to have a date column in the table where you're implementing incremental refresh. This date column can be either datetime or integer data type. Query folding must be in place. Query folding, one of my favorite topics in Power BI, but yeah, it's out of the scope here, and it's not tested really on DP-600, but keep in mind that query folding must be in place because for incremental refresh, we are using date range parameters, and they must be translated to a where clause in this SQL query. And it allows defining incremental refresh just on a single data source, so you can't combine multiple data sources here. Okay, so we are done with all the skills measured, and now I hope you are ready to play some games. Special thanks to my friend Ricardo Rincon from Barcelona, and I'll explain why. So I expected that a lot of people will be here, and unfortunately my license for creating quiz supports up to 100 participants. And then I asked last evening if someone has a license for a larger number of participants, and Ricardo immediately reached out to me and offered his license for Kahoot. And therefore, huge thanks to Ricardo for basically enabling us to play this quiz. Let me just quickly go and okay, so there you go. We have, just to give you a short hint, we have 10 questions, but we have first question which is like a warm-up, so just for you to see how it works, and then after that we have 10 questions with points. So yeah, all the things that we covered in the previous 4 hours will be included. So hope you are familiar with Kahoot. You can scan the QR code on your screen, or you can go to kahoot.it and then enter this game pin. I'll give you a few minutes for everyone to join. You don't need to provide your real name if you don't want. Feel free to be Fabric Ninja or Fabric Master or whatever. Come on, I want to see at least 101 participants because of the license. So I don't feel bad bothering Ricardo. Okay, then I'll slowly start. So the first question is just a warming up for you to understand how Kahoot works. Here there are no wrong answers. So whatever you mark, this will be a correct answer, but no points. Yeah, great point from Shannon. This game is based on both speed and accuracy. Just for your information, yes, that's a great point. I forgot to mention that. So essentially, it's important that you are fast. Obviously, the most important thing is that you provide the correct answer. But after that, it also matters if you're fast or not. Okay. So now I hope you are ready. Let's play. Question number 1. Apologize. Questions are displayed as photos because of the character limitation for the question itself, but I will read it aloud so everyone can understand. You have a Fabric workspace that contains a Power BI report. You need to modify the column names in the Power BI report without changing the original names in the underlying Delta table. What warehouse object should you create? Column store index, table value functions, schema, or view? Okay, most of you answer correctly, so it's a view. Basically, with the column store index, we don't change column names. With table value functions, we don't use that, or schemas to change the column name without changing the original names. For that, we use views. Okay, we have a lot of correct answers. Let's jump straight into question number 2. You need to ingest data into Lakehouse from a large SQL database table that contains 500 million plus records. Data should be ingested without applying additional transformations. Your solution must support a low-code approach and minimize effort. What should you use? Copy data activity, data flows gen 2, notebook, or SQL stored procedure? Great point from Pam. All of you are getting the answer right. Go schedule your exam. Yes. Take it before New Year. Yeah. Okay. Again, most of you got it right, but that's why I love using those quizzes. So that helps me to understand if I explain certain concepts in a proper manner or not. Obviously, here not. I'm happy that just 2 of you answered notebooks and SQL store procedures. The question says your solution must support a low code approach. So notebooks and SQL store procedures are code first approach. Then it boils down to data flows gen 2 versus copy data activity. In this case, it says without applying transformations. So in those cases, because we want to minimize the effort, copy data is the way to go. So data flows are their primary use case is when we need to apply transformations. Okay, let's move on to the next one. Number 3. You have the report sales with an Excel file as a data source. The table contains the following columns: product ID, product color, product name, product category, and sales amount. You need to create a star schema model. Which column should remain in the fact table? Data modeling 101. Okay, most of you got it right. I'm happy because of that. Congratulations. No need to explain anything. Let's move on to number 4. You plan to implement a dimensional model in a warehouse. The solution must be able to perform point-in-time analysis. Whenever customer status changes, the change persists in the customer table and a new row is added. What slowly changing dimension type should you use? 0, 1, 2, or 3? We talked about that. I moved from Belgrade to Salzburg. Now I plan to move to Spain. Which slowly changing dimension type should they use to handle my records? Most of you got it right. Yes, for most of analytical scenarios, slowly changing dimension type 2 is being used. This one adds a new row to the existing table and handles point-in-time analysis, so you can go and check what happened previously. So correct answer is type 2. No changes on the top. Okay, this will be a tough battle, but I have a little secret. 2 questions are evaluated with double points, and the next one is with double points, so be careful. You are developing a Power BI semantic model. 2 tables in the data model are connected with a relationship and a single direction filter. You need to establish the bidirectional filtering between the tables. Which DAX function should you use? Good question. 47th place. What can I do to be in first? To be faster and that others are providing wrong answers. It's as simple as that. Yeah, DAX. Yeah, no. That's why this one is double points. Oh, okay. It was easier than I thought. Yeah, cross filter. Exactly. Cross filter is the correct answer. We are using cross filter function to enable bidirectional filtering for the specific calculation. Let's see if we have any changes. So yeah, Milan is first now. Cool. Let's move on to number 6. You're designing semantic model with 50 measures, such as sales amount, order quantity, and so on. For each measure, you need to create the same set of time intelligence calculations, such as month to date, year to date, etc. The solution must minimize the effort and maintenance. What should you do? Okay, great. Not creating a measure folder in the report model will not help in this case. So calculation group, this is a perfect use case for calculation group. Okay, let's move on. We are getting closer and closer. Which of the following T-SQL functions returns the rank of each row within the result set partition with no gaps in the ranking values? Yeah, this one was tough, I have to admit. Yeah, the key thing is with no gaps in the ranking values. And as I shown you in this example, dense rank is the function that continues to rank each row within result set partition with no gaps. Rank will introduce gap. Row number simply goes 1, 2, 3, 4, 5, and lag is the offset function, so it doesn't have anything to do with this. Okay, we have textile as on the first place, but very tough battle with others. Stay tuned. The next question is here. You are using deployment pipelines to move fabric items from dev to test environment. Which of the following fabric items is not supported when deploying the content? Make sure to learn this for the real exam. That's why I included a question like this today. Okay, yeah, fair enough. This was a tough one for those of you who were not looking into this slide when I introduced the list of items that are supported currently for deployment pipelines. So everything from this list is supported except dashboards. So dashboards are not supported within deployment pipelines, and they will not be transferred to the next stage. Okay, tough battle. We have two more questions. You are developing a Power BI solution within a large organization. You need to ensure that the solution supports proper version control and CI/CD requirements. In which format should you save the Power BI file? PBIT, PBIX, PBIP, or PBIDS? We talked about this topic at the very beginning. So maybe it's not fresh in your mind, but I hope you carefully listen what I was talking about. Yes, yeah, most of you got it right. I'm happy about that. Yes, it's PBIP. It's PBIP. That's correct answer. Final question. So before final question, let's see the leaderboard. The last question is also double points, so be careful and be ready to answer this, and let's see who wins the game. So the last question, final question. You are working with a KQL query set in Fabric. You need to enrich the existing table by appending the calculated column at the end of the result set. Which KQL operator should you use? Calculated column at the end of the result set. Question from Sahar. So there won't be any Spark questions in the exam, right? I can't tell you because I took the exam at the beginning when Spark was still there, but officially there is no more PySpark in the exam. I'm not sure if they removed all the questions from the old version. I can't tell you that, but officially no PySpark. Most of you got it right. It's extend. Append will add new rows, not new columns. So append is adding new rows. Extend is adding a calculated column at the end of the result set. So that's correct answer. Let's see the final leaderboard. Number 3, Amino, congratulations. Great result. Krista, congratulations. And who's the winner? Yoshko, congratulations. Great work, all of you. And thanks everyone for runners, Milan and Textile. Great battle from the very beginning. So yeah, congratulations to all, and thanks for participating in this quiz. I hope you enjoyed it and again learned or refresh some knowledge that we covered today. So slowly wrapping up, we are already above the time. So some practical exam tips from my side that I want to share. Make sure to prepare the room. This is relevant for online takers. If you go to testing center, of course, this does not apply. But for online takers, if you take the exam through Pearson VUE, they will ask you to remove everything from your table and everything that is in reach of your hands. Also, no multiple screens and so on. So make sure to spend some time preparing the room for the exam. You can use Microsoft Learn during the exam. That's great news. So it's an open book exam. You can use it, but don't let this waste too much of your time. I heard many people telling that they rely too heavily on Microsoft Learn and they spent a lot of time to find certain things in Microsoft Docs. So this means that only if you are not sure about 2 or 3 options and you know what to look for in documentation, go and look for it. But if you are relying like I have 50 questions and I plan to take 30 of questions with Microsoft Docs through the exam, better don't take the exam before you are ready. This is good just for finding answer for a few questions. Focus on understanding specific functions, index, tsql, and KQL, and their order of execution. There are many questions with, drag the correct order or fill in the blanks or stuff like that, where you really need to know which function does what, like cross filter, for example, and what is the order of execution. So if you write a window function in tsql, it's always over, partition by, order by. It can't be in different order. So make sure to familiarize yourself with this part. Understand when to complete a specific task in a certain way. For example, when to ingest data with pipeline versus notebook versus data flow gen tool versus using shortcuts. Remember, we were talking about all of these features. So read through the question stem, read carefully, and understand what needs to be done. Is it low code? Is it code first? Is it with data transformation or without data transformation? And so on and so on. Some final remarks where to go from here. I would say the best way to learn is by doing. So set up your Fabric trial account and try it for 60 days for free. That's amazing starting point. There is a link to activate your Fabric trial capacity. Microsoft Fabric official documentation is a tremendous resource for learning all the stuff related to Microsoft Fabric, not just this which is relevant for DP-600. I'll be doing a training on Microsoft Fabric as a whole, not from a perspective of analytics engineer, but as a whole. So we cover real-time intelligence, data science stuff like semantic link and so on. This is not a free training. So yeah, if you want to learn more about Fabric, that's the one. And yeah, there are many free learning resources from community that I want to share. Of course, you can refer to my blog, data-mozart.com, but I would also like to share a few more learning resources. Andy Cutler, who was here moderating serverlessSQL.com. Our friend Kevin Chant has great blog with many topics covered at kevinrchant.com. And also Will Needham, probably most of you know him. He's running Learn Microsoft Fabric YouTube channel. It's full of fantastic resources. So you can just scan QR codes for each of these links and go directly there and pick up where we left off. So it's wherever you go from here, it's good. That was all from my side. One last thing, I would like to thank again my friends who joined and moderated this chat. This couldn't be possible. This live stream couldn't be possible without you. So my heartfelt thank go to all of the friends who managed chat today. Thanks to again to Ricardo for the license. Thanks to Pam and Shannon from Microsoft for joining and helping to promote this workshop today. And I wish all of you good luck with the exam. And I would like to hear if you pass or not. So please share this information with us. We would like to hear from you if you pass the exam. But I sincerely hope that you are going to smash it after this workshop and after spending some time learning through Microsoft documentation. That's all. Thank you so much, and have a great weekend.